Okay, good morning, Astronomy 1020, and welcome to your first lecture with me. I'm recording this video so that people who missed the class or slackers or students who are taking the night class will be able to watch this later and catch up on what you missed. That could be helpful for us. So the videos will always be available
Do you have a key?
On YouTube and on the Blackboard page following
You
our...
don't have a key.
Hey, whoever's in the background there, one of you trolls who aren't sharing video, you should mute yourself until it's time to talk to me. Maybe we should go over the etiquette of this thing here. It's good to mute yourself until you want to contribute or say something. You should feel free to talk anytime you want to, but unmute yourself, talk, and then mute yourself again. Because with, I don't know, maybe like 40 or 50 people in the same Zoom, if everyone's got background chatter, it will be hard for us to concentrate. So someone in the background forgot to mute themselves. Deal with that. Okay, good. Looks like we're all set there. So let's go ahead.
If you have a question, do we just raise our hand if you see us?
You could raise your, or even just blurt something out, just like you did. Is that Cara Jo?
Yeah, well, I didn't do it. It was somebody else. But yeah, I'm Cara Jo.
Okay. Oh, sorry. Cara Jo, that, or whoever said that, that works. Just, you could raise your hand, but you could also just unmute and say, hey, Brendan, I want to ask you something. You know, if you start fighting with your kids or yell at your dog or something, that's going to throw me off my horse. So, okay.
I think you actually have a mute all button too. There should be a way you can mute everybody.
That's a
Just
good
saying.
point there, Devlin. They probably took that away from me too. Things got considerably weirder once I joined the CCRI system, but I'll find that mute all button somewhere. Sometime. Okay. Anyways, I don't want to mute all because I want you guys to be able to talk to me. That's an important part of a class. Just, I'll let you guys monitor it. Okay. I'm sharing my screen. I want to share a slide with you guys. Function F5. Let's talk about this thing here. I want to know, do you guys know the difference between astronomy and astrology? Now, my old friend Chris, he better know because he took my solar system class. So you hush down, Chris, because you know what's going on here. But the rest of you guys, I got to figure out what you know. Do you know the difference between these two things, astronomy versus astrology? Doesn't have to be.
I do.
Okay, who's talking to me?
It's me.
Oh,
Hi, I'm Kate.
Kate, what do you think?
So astronomy is like actual science of the stars, like what we're doing. And then astrology is like the zodiac signs. So like Cancer, Gemini, Aries, all of that.
I agree. I fully agree. So actually, if you guys aren't familiar with the Zoom system, I'm going to occasionally be taking notes with you on my dry erase board, and I think you should write down in your notebooks whatever I write down. It'll be important, okay? If you're not familiar with the Zoom setup, right now I have you guys in gallery view so I can see all your little Hollywood squares. But we can go into speaker view, and if you double click on my little face, we can go into locked speaker mode, and that's going to be the best way for you guys to take notes, okay? So I think we should start off the class by taking some notes on the differences between astronomy versus astrology. Hopefully you guys can read that clear enough, okay? Now, Kate described astronomy as a science, and that's good. And she related astrology to the so-called zodiac signs. You might think of the zodiac as being your first $10 vocabulary word that you guys are going to learn with me, okay? So, cha-ching, you're already starting to get your money's worth here. The zodiac is going to be an important vocabulary word. All right, now someone else wants to join. Here we go. Okay. Astronomy is a science, and it could be considered one of two types of sciences. It could be considered a natural science, or it could be considered a physical science today. And you guys may not know the difference between those two things, but historically there was a great deal of emphasis made on the difference between a natural science and a physical science. A natural science would be something like geology or maybe even biology, where you couldn't directly manipulate your environment, but you could observe with your eyes, and you could count the number of peaks on a mountain range, or maybe you were Charles Darwin and you could count 1, 2, 3, 4 turtles on the Galapagos Islands. Natural science is you kind of observe nature. A physical science is something more like physics or chemistry, where you build a block or a lever, or you cook something up in an Erlenmeyer flask. You directly manipulate your environment. Of course, we can't exactly touch the stars, so astronomy has something to do with the natural science. But today we've actually built spacecrafts that have explored the surfaces of planets, and they've skimmed. Right now, the Parker Solar Probe is a satellite that's on a journey to fly through the atmosphere of the sun and collect plasma from the sun itself. So in a way, we have touched a star. We've touched our own star. And therefore, astronomy can be considered like physics, a natural science. Anyways, I'm just waxing philosophical here. The zodiac and your signs refer to actual stars in the nighttime sky. So Kate or anyone else, what makes astrology, I mean, the zodiac signs are important in astronomy as well as astrology. There's another important difference here that we're missing. How about you, Kara Jo?
Numbers, like everything that is in astrology is all numeral.
Everything that's in astronomy is numeric as well. I mean, at its very essence, you will learn today during the course of my lectures that what differentiates science from other types of disciplines is measurement. Measurement is at the heart of what science is all about. So unfortunately, that's not going to be good enough either. We need some other ideas.
I think astrology is like more focused on like people than the stars, kind of, because it's more about like how like the star placements when you were born, how like that affects you.
That's right. Okay, so that's pretty good, Lydia, if that was your voice I was hearing.
Yeah.
It has to do with people, but let's not forget that people they're little bug-like organisms living on the surface of a planet we call Earth. Earth is a component to the universe. And so if I wanted to be incredibly disputatious, Lydia, I would say that people also fall into the jurisdiction of astronomy, but I'm obnoxious like that. Honestly, you did a great job there. Let me show you the way I think about it, okay? So let's go back to our share screen here. I like to think of this is what your everyday astrologer looks like, okay? So this is a picture of a typical astrologer, okay? And the message of astrology goes something like this. It goes, everything's gonna be great, you will be rich, okay? So this is what astrologers tend to look like. Now, by contrast, this is what an astronomer looks like, okay? This is Edwin Hubble. He's a famous astronomer who discovered that the universe is expanding when he observed the velocities of galaxies. You'll discover the message of astronomy is not the same as astrology. The message of astronomy is the world's going to end and you will all die when the sun enters its red giant phase. So you can see that the message of astronomy is not quite as uplifting as the message of astrology. And yet people tend to get these things confused for a bunch of different reasons. Well, maybe we could read about them in a magazine. You can read about astrology in a magazine like Dell Horoscope here. And in a magazine like Dell Horoscope, you could find that in your supermarket magazine checkout rack, okay? While you're waiting to check out your frozen peas, you can read all sorts of things about Uranus moves into Pisces. Expect the unexpected. Who would expect the expected anyways? Or you might find other things like love is waiting for you in aisle 5, or it's time to sell that condo in Florida. I don't know, whatever they put in these things. If you want to read some theories in astronomy, you're going to have to go to a different sort of periodical. You're going to have to get a subscription to Science or Nature or the Astrophysical Journal. One of the first things you'll learn is that there's a difference in price. A subscription to this magazine might cost you $2.50. A subscription to this thing, well, It's so embarrassing they won't even put it on the cover. That you have to pay hundreds of dollars for a subscription to this magazine. And let me tell you, my friends, you get what you pay for. The quality of information in this magazine is much greater than the quality of information in that magazine. And the reason why is because to publish an article in astronomy, you have to submit to what we call a peer-reviewed journal. You first have to do something, okay? You've got to go out to your telescope and you've got to make some observations and you've got to collect some photons. You've got to do some statistics and test hypotheses. And then when you're ready to go, you have to submit the work to a body of enemy professors who are out to get you. And they're going to comb through your research looking for any possible mistakes you might have made, right? And only after they've begrudgingly admitted, well, the theory may be flawed, but the research is technically sound, then they will let you in. Okay, sorry, I'm having to deal with admitting people here. Okay, any case, I don't know what the threshold for publication is in Dell Horoscope. I'd imagine that you walk into the editor's office with an energy crystal on your forehead and you say, bro, I'm like deeply in touch with the stars and the cosmic vibrations between all souls. And the cigar chomping editor says, I love it, 25 cents a word, your deadline's Monday. That's the threshold for publication in Dell Horoscope, okay? So it's not the same kind of thing, all right? And yet people tend to get these things confused because they both have to do with stars and planets. They haven't figured out how to monetize galaxies yet, but I'm sure once they do, the astrologers will throw those in there too. Like, once you find out that your Milky Way is in Gatorade, it's all over, okay? Then you've really done yourself a bad. Okay, so anyways, what is this? This is a symbolic representation of 13 famous constellations. And these 13 constellations are part of the zodiac. There are many more than 13 constellations on the nighttime sky. The International Astronomical Union recognizes 88 total constellations in the celestial sphere. So in other words, if you look out into space in all directions, there's a limited number of directions you can look out from Earth. We've created this construct called the celestial sphere. It's a model of space. And the International Astronomical Union recognizes a total of 88 constellations on the celestial sphere. There's 88 constellations for you to choose from. So the question is, why are the astrologers so obsessed with these 13 constellations? Why is everyone so worked up? Oh, does anyone know? Does anyone have a thought? Sagittarius, Capricornus, Pisces. Why is that so important? Why can't I be a Vulpecula? Why can't I be a Camillo Pardalis, right?
Well, I know that I remember reading somewhere that every so many thousands of years, the North Star, the main star that we use to devise our constellations, changes. So we need one of those ones, right?
That's absolutely correct, Wyatt. It's got to do with gravitational interactions between Earth and the Moon that over long periods of time cause Earth, well, not the whole sky. Hold on a second here. I need some gizmos. The Earth, through gravitational interactions with the Moon, goes through a 26,000-year precession. Earth is slowly wobbling on its axis in the same way that a spinning top does. And not only does that change where the North Star is, or it changes which star is the North Star, it also shifts the constellations of the zodiac as well. That's why today, historically, there were 12 zodiac signs, and today there is a 13th zodiac sign called Ophiuchus. But Wyatt, although your observation is important, and although you did talk about something cool that we want to talk about, no one's really put their finger on the nail here of why these constellations are important to astrologers. And I thought someone out there, knowing that you all love and worship astrology, birth months. Yes, Kevin, it's got something. Kevin chats in the chat room birth months. It's got something to do with your B-Day.
Isn't it it goes on the path of like the sun, kind of.
That's very good. Was that you, Lydia? Was that your voice? Lydia, that is exactly correct. And to help explain what Lydia's talking about, I wanna flash forward here to a slide in my slideshow. Let's all check out slide 58 together. This is going to be important. What makes the constellations of the zodiac special to both astronomers and astrologers is these are the constellations through which the sun seems to travel over the course of 1 year. As you know, Earth orbits the sun, and it orbits the sun on a quasi-circle called the ecliptic. The ecliptic is shown in green here as a green circle. As Earth moves around the sun during the year, the sun appears to be projected against 13 different constellations. And I'm not talking about that daily motion of the sun. You know, the sun rises in the east and it sets in the west. That's a different thing. That's because of the spin of Earth. During a single day, the sun would be kind of pinned to one of these constellations. But if you carefully observe the position of the sun night after night after night, you see that it slowly begins to drift backwards along the constellations of the zodiac. The reason why this was important to ancient people is because, well, think about it. The sun is like your energy god, right? It brings warmth to your body. It brings light to your crops so that your civilization can subsist. If the sun is traveling, what about Ra? The Egyptians worshipped Ra, or Helios in his fiery chariot, excuse me. If the sun is traveling through these constellations, the argument goes that these constellations must be important or maybe even sacred. And this brings us round to the central premise of astrology. And I think we're going to actually write that down here, okay? So let's write down the premise of astrology. It's that the location of the sun against the background stars and here's the real kicker. This is where you know what's going on. It's on your B-day. And that's your birthday, of course. The location of the sun, oh my God, this is so irritating. I knew this was going to be completely obnoxious. Letting people in and out is going to be, I'm going to complain about it a lot today. I'm going to fix this somehow. Anyways. Okay. The location of the sun against the background stars on your birthday will determine your personality type and or your destiny. And that's a pretty bold statement. It means that if you were born in December and the sun was located in Sagittarius, did I get that right?
Yes, yeah. The beginning part.
So if you were born in December and the sun was in Sagittarius on your birthday, well, that's going to mean that you like puppies instead of kitties, and you like ice cream cones instead of popsicle sticks. And this is going to determine, you know, your personality type. The difficulty with a statement like this statement is a statement about physical observable objects that are part of the natural science universe. In other words, let me explain what I mean by that. The sun is a physical object that any capable person can go out at night and observe. You can also observe the positions of background stars. And your B-Day is kind of like a historical fact. You can look it up on your birth certificate or in the town hall registry. Now, personality types are a little bit squishy, you know, like people have a habit of wiggling out of the boxes you try to preconceive them into, except for these boxes. Am I right? You're never getting out of this class. All right. So any case, the personality, there is a noble theory or a noble science of psychology. And the psychologist attempts to measure personality types, right? They give you a Miggs-Bryer personality test, and they ask you, do you like puppies, or do you like kitties? Do you like popsicle sticks? Do you like ice cream cones? Do you like water slides? And then they can filter you through a probability matrix and say, all right, you're an alpha dog, or she's a beta fish. Okay, so they attempt to do this, and it's a young science, but it's trying. And your destiny is kind of like, well, you just wait until you die, and then you can ask, well, did he do anything interesting or what? And it turns out if you go out and observe all these things, if you look at the sun on your birthday and you compare it to your personality type, if you do it right, you quickly discover that this is a false statement. In fact, there is no relationship between the position of the sun and the stars and your personality type whatsoever, nor does it affect your destiny. It's just it's plain as a pikestaff if you actually go out and perform the observations. So I'm sorry, just because you're born on Albert Einstein's birthday, don't make you Albert Einstein, okay? And you could even like the simplest thinking person will quickly realize that there are way more than 12 personality types out there, right? Like, I don't even think there's a sucker born who believes there's only 13 types of people and that's it. And that's why they got to mix it up a bit, and they put the moons in there, and oh, it's your Mercury's in Gatorade, and Jupiter's going through the second house of Aquarius. Like, it's snake oil, my friends. It's snake oil. And that's why philosophers have dubbed astrology as a pseudoscience. It's not even cool enough to be called a mythological worldview or a religion. It's a system of belief that uses technical jargon to sound like it's doing something, but in actuality, if you hold it up against its own self-scrutiny, none of the statements that it makes bear fruit. They don't actually work. Anyways, on the other hand, maybe we could think about something different, like this. What's up with this thing here? Anyone know what this is?
That's is it the Crab Nebula or?
Good try, but it's not the Crab Nebula. It does have another animal name though.
Horsehead Nebula.
Yeah, who said that? I can't see your little faces. I mean, I can't hear. Who knew it was the Horsehead Nebula? Who's your name? Where are you?
Me, Chris.
Oh, Chris. Okay. I can only see a few of you at a time. By the way, thank you for sharing video. Sharing video is actually really important. It means that we can talk to each other and we can get to know each other. The video thing is actually really important. I know some people are shy or hungover. Maybe you're eating Cheerios in your PJs. I don't care. Being able to interface with each other and see each other's faces will help make a sense of class community. Also, we get to see people's cool pets. Like, where's that guy who had a cool dog? I think he hit himself. Some guy had a cool dog. I wanted to find out about that dog. Anyways, yeah, this thing that you see here, this is called the Horsehead Nebula. And it's named after the iconic seahorse-shaped cloud of hydrogen gas. This, my friends, this is the real universe. This is real reality. 99.999% of the universe are weird cold clouds of hydrogen gas floating in the dark void of space, massive spheres of plasma generating radiation and nuclear reactions. Nature is freaky and weird. What is all this stuff? I don't know, but it's more real than you are, okay? Because there's way more of this than there is of you. Believe it or not, all of this stuff, it's all connected to you. You are formed from all of this material. It's part of your body. So maybe we should find out about that, huh? Maybe we should find out what's going on in the real universe and see what's been happening outside our little planet here. Well, in any case, I don't know what you guys are planning on learning this semester, but let's start with something real important. Astronomy does not equal astrology, okay? They are not the same thing. And if you write me an email and you say, "Dear Professor Britton, I am in your Astrology 101 class," I'm going to reach over to my computer. I'm going to hit delete, delete, delete. I'm going to pretend I didn't know you anymore, okay? You are not in astrology class. You are in astronomy class. So welcome to Astronomy 1020. In fact, this class is about stars and galaxies. It's the sister component to my Astronomy 1010 class on the solar system. And no, you don't have to take the solar system first. I know one is 1010 and one is 1020, but they don't depend on each other. As I was explaining to Chris today, these two classes are like a tree. There's a trunk of the tree where we all learn the same basics of astronomy, and then they split out into different directions. So if anyone out there besides Chris has taken the solar system class, some things will be familiar at first, and then they'll start to get weird again, okay? I will be your host through this course, and my name is Brendan Britton. Here's an action shot with me in front of the CCRI telescope, which is in the woods at at the Warwick campus. So for years, I've run the public open night here as well at the Margaret Jacobi Observatory. We actually have a pretty decent sized telescope at our campus that I'm totally not going to be able to show you because of the COVID-19 pandemic. And that makes me very sad. But I'm hoping at some point, all of this will quiet down and I'll be able to take you out to this thing and you'll be able to look through that eyepiece and see some really beautiful sights. If you've never gotten to look through a telescope before, it's a treat. When you see the moon for the first time and you can see all of those craters and all that detail, it's mind-blowingly amazing, you know? So in any case, maybe we'll get around to that. Listen, I've been teaching this class a long time and I know a whole bunch of things that you're going to be interested in, including how to have a good semester and how to get good grades. You're just going to have to trust me and listen to me, okay? Now, enough about me. Who are you? Well, I know Chris, but besides that, the rest of you are pretty new to me. So give me time. I'll be able to learn your names if you share your video with me. If you don't share your video with me, you are what I consider a troll. And you can troll the class if you want. That's fine, but I'm not going to get to know you that way. So I may forget you before I even get to know you, okay? So whoever you are, though, whether you're a troll or whether you're a real-life human that I can interface with, I'm going to treat you with the dignity and the respect that you deserve because you paid $500 to listen to me talk about seahorse-shaped clouds of hydrogen gas in space. Thank you for your patronage. I appreciate it. Whoever you are, I hope you come to class on Tuesdays and Thursdays with a calculator. And I'm going to tell you oh, yeah, Kaitlyn. That's my girl right there. She's got the Casio FX260 Solar Mach 2. That's going to be, Kaitlyn, take that right out of the damn packaging because you're going to need that. Actually, let's do a show of hands here. Wait, let me unshare for a second so I can, hold on. People are chatting me too. Devlin, if you don't have a calculator, you will have lost spiritual points with me, but we'll allow you to stay in the class and you're just going to have to muscle through. How many of you do have that Casio calculator? Can I see a show of hands here? Chris, Kara Joe, Emily's got it. All right, Ty, yes. Paul, you got it? Thank you. So many of you have your shit together. It's mind-blowing. Okay, take them, Kara Joe, you got it? Or,
I have a question.
Yeah.
I have a question. I have the other calculator, what is it? The Texas Instrumental. Is that something that we could use, or it has to be the Casio?
Okay, listen. Here's how this works, okay? This class, as I'm about to mention in a second or two, is going to involve a teensy bit of math. And, oh, Nate with the chickens says hi. Tell Nate I love that guy. He would have his chicken in the class last semester, and it was really funny. Okay, show me your pets. I love them. Listen, guys, there's a lot of you. They doubled the class enrollment 2 weeks. Like, I can already see like 20 of you, and there's another 20 people hidden back there. And there are people that aren't joining us that are in the night class. I'm going to be giving you specific instructions on how to use this calculator. And if everybody has a different calculator, it's going to be absolute effing chaos. So much chaos. Oh, Kara Jo, what's your kitty's name, Kara Jo?
Meow.
I love it, Meow. Okay, we're going to teach Meow how to punch the buttons on this thing, okay? Now listen, If Meow can do it, you can do it, but you can only do it if you have a Casio FX260 Solar available in slate gray, or the Mach 2 version is white. There's even a hot pink version if you want to jazz up your life. Okay, listen, you gotta have this calculator. Unfortunately, I do know how to use every calculator out there, but I can't give 20 sets. I can't give 40 different people different instructions. You guys will get bored. It will make this class a horrible experience. Luckily for you, this calculator, it costs $8. That's less than the price of a pack of smokes, okay? You can get yourself a Casio FX260 solar calculator and discover all kinds of things about the universe with me. And they have it at Walmart. I think it's $8. Where'd you guys get yours? Paul, where'd you get yours?
I got mine over at Staples. It was about 10 and change.
Oh, wow. Staples are really milking you. Okay, so it's $10 at Staples. It's $15 at the bookstore, right? So this is not the most expensive thing you're going to buy, but this is the most important thing. And I need you to have it right away because I'm going to start training you today on how to use it. Now, Devlin, if you don't have it, yes, you will be missing out a little bit. You're going to have to use a phone calculator or something to try to keep up with us, but it's not going to be pretty. And the more time you have exposure to this, the stronger you will become. So I need you to get this. So Devlin, can you get this worked out by Thursday?
Yeah, I'll have one by tomorrow.
Killer. All right, that's what I want to hear. Can do. Anyways, you're going to need a calculator. The other thing you're going to need to do this course is a positive attitude, because every single course involves a bit of work, and you signed up for this, okay? And if we do it together and we have a positive attitude, we can actually have fun. Thank God I don't have to teach you accounting or QuickBooks or something. I'd probably just end it all right now if I had to do that. I am going to teach you about stuff that is bona fidely cool and interesting to talk about. So when the going gets tough, just remember, you know, we're gonna work together. We're gonna make this okay. We're gonna pass. We're gonna get our credits, and we're gonna move on with our lives. So we're gonna learn about the universe. And as I was saying, the universe is a cool place to be and some cool stuff to talk about. You're gonna learn about stars. You're gonna learn more about stars than you ever wanted to know. But I can't start off with stars right away because stars are complex balls of plasma. And you're going to need to build up your science muscles for us to be able to have an intelligent conversation about stars. We're going to learn about the sun. That's our star. And not only have we observed it for hundreds of years, but we've also now built machines that can fly through its outer atmosphere and sample bits from the sun. So there'll be some cool science reveals during the course of this semester. Eventually, we're going to want to try to talk about galaxies, and galaxies are really cool. We'll learn more about those in a minute. And if time allows, we might even be able to talk about larger scale structure, like galaxy groups and galaxy clusters. Hell, the universe is the totality of all the galaxies and stars and planets and gas that exist. The universe is like everything by definition. And that means our subject of inquiry is everything that ever was, is, and shall be. Our spiritual horizon is infinite, okay? We can talk about anything, and it's literally in the subject of astronomy. And that's why you're going to need to get a calculator, because if you're going to learn about the universe, it's kind of a big place, and we're going to have to take some measurements. And once you start taking measurements, you get a hankering to do some math. Math is one of the parts of this course that makes it interesting. It's where you're going to learn some real life skills that will make you a stronger and more powerful human. I'm not going to assume that you know a lot of stuff. I'm going to assume that you're a reasonable person like Meow, who can find the multiply and divide keys on the calculator and press them when I say go, okay? If you can do that, you can handle this course. All you need is the Casio and a positive attitude. Because nature is interesting and beautiful. And when I look out at a galaxy like this, I get inspired to know more about nature. What's going on there? What are all these things? Why does it look like that? Well, if you want to learn about what makes a picture like this work, you're going to need to develop a taste for some pictures like this, the occasional diagram, the occasional math equation that will appear in this class. That's what makes astronomy interesting, is that we can look at these massive structures and we can find ways with numbers to relate them and scale them down to our everyday life. But you can't do that unless you have one of these. So remember, the model that you're looking for is the Casio FX260 Solar, available wherever scientific calculators are found. First of all, this calculator is powered by the sun, and that means it's somehow symbolically appropriate for our astronomy class. Secondly, it will never run out of batteries during your exam. And thirdly, it has all the keys that I want to teach you in an easy to locate place. So while the Texas Instruments does qualify as a scientific calculator, it's not whoever had that one. You can use it for today, but it's not going to be good enough. All right, Cole's busting out his, yes, Cole has the calculator. All right, yes, that makes me very happy. Okay, so before we talk about any more stuff related to this class, before we learn about solar systems and galaxies, maybe we got to talk about the classroom system so that before we get going on our journey through space, you guys are clear about how I'm going to grade you and what I expect of you during the course of this semester. With that in mind, it might be a good idea for us to take a peek at the syllabus. So if you joined us late, remember that you can go to Blackboard, you can go to the Syllabus and Schedule tab, and let me erase that drawing there. Okay. You can right-click the syllabus and the schedule, and I want to talk to you guys about that. So let's take a peek at the syllabus. The syllabus has all sorts of really useful information about how to contact me. So here's my name, if you forget it. That's my email, and this here is my personal cell phone number. You can text me, you can call me if you get in a jam. Because we don't have the option of meeting in person, I think it's important that you have ways to get in touch with me. And as long as you don't abuse it, I don't mind if you send me a text or email or whatever. If you get into a jam, I answer student emails all day long while I'm riding my bike, while I'm getting groceries, okay? You can text me whenever. You just might have to put up with me in some state of inebriation or something, okay? But I will do my best to get back to you as quickly as I can. And that's important that you guys have a way to get in touch. I'm also down for one-on-one Zoom chats. If you have some one-on-one kind of stuff you need to discuss with me, anything's on the table. Let's take a look at what we do here. Our lecture meets every Tuesday and Thursday from 11:30 to 1. But I have some very different ideas about how we're going to prosecute the lab here in this class. There are many of you who signed up for section 001, which is the Monday lab, and many of you which signed up for 002, which is the Thursday lab, Tuesday lab and a Thursday lab. And some of you are even in the night class. Now, the reason for that is because we were limited by the number of seats in our laboratory classroom. But here on Zoom, if you think about it, we can all do our labs together. In fact, our lab room, we're going to do a lab today, is now right over there at my desk, where I'm going to set up a bunch of equipment and take measurements, and we're going to kind of do it together as a group. So we are all going to do our labs together on Tuesdays. After lecture, the lab is scheduled from 1 to 3, but usually the labs, I can get them done in like just about an hour. So think 1 to 2-ish, okay? If you have obligations, if you're in the Thursday lab and you weren't expecting that, well, you'll have to watch the video later. I will be recording this. The reason we're doing this is because on Thursdays, we're going to have lecture from 11:30 to 1, and then in place of the Thursday lab, we are going to have our all-important office hour sessions. The office hours are where we do our homework together so that I can make sure that you do your homework right and you get good grades and you pass this class. If for some crazy reason you want to do the homework on your own and you want to be miserable and get wrong answers and be frustrated, well, you are welcome to do that. But the rest of us will do our homework together and we'll get it done faster, better, cheaper, and it'll make sure that you get good grades and pass this class, every single one of you. Don't take it from me, take it from a former student who was in my solar system class. Chris, what do you think about those office hour sessions?
They work really well, especially if you're having a really hard time with the homework and you're not really understanding it. It works really well for trying to figure it out anyway.
Even if you are understanding it, we can get things done in a special way there. If I was a student, if I was a student at one point, so I remember what that feels like, I would like to get it all done in-house, and then when the class is over, move on to other parts of my life, because you guys have jobs and families and all kinds of craziness. Let's do it all together. We'll do our labs together, we'll do our homeworks together, we'll get it done, and then we don't have to be stressed out. We can just have a good time learning about space, okay? So with that in mind, let's take a peek here and learn about the breakdown of your grade, okay? So attending lecture, you don't get any points for that. That's where you learn, okay? That's where you learn from me how things work. And if you'd like to join me, then I'd love to have you here from 11:30 to 1. You're gonna need to come to lecture so that you can understand how to punch the buttons in your calculator, if nothing else. We do labs on Tuesdays. The labs are worth 25% of your grade. We will do some type of exercise together. I'll set up some special equipment. I'll use my cell phone camera to take measurements. And when we do labs, let me show you how that works, because some of you might not exactly know the drill here. We're gonna do a lab today. And if you guys have a printer, what you should do is you should go to the lab tab. There is a special book for the lab, but it's like old and it's out of print. And because we don't need the entire book, I've just kind of photocopied the pages that we're gonna need and provided them for you. So look over here. This is our lab that we're gonna do today on powers of 10 and measurement. If I right click on this, I can open up this document here and I can actually hit print and print it out. That's probably what most of you should do. And then we can kind of write down the answers as I do the lab with you. And then you can take your cell phone and you can take a picture of it and you can upload it to Blackboard. How many of you have done something like this in another class? I know some of you have had Zoom classes where you had to submit work. Not as many as I was thinking. Okay. If not, I'm gonna walk you through. At the end of lab today, I think we'll have a little breakdown where I show you guys how to submit stuff. It's very important that when you photograph your assignments, you photograph them as a JPEG. I can read JPEGs, I can read PDFs and Word documents. How many people out there don't have access to a printer? I bet there's a few of you. Devlin, Christopher, Carajo. Okay. If you don't have access to a printer, you've got two options. The first is, okay, Tiffany, I hear you. The first thing you could do if you don't have a printer, the brute force way is you could just kind of copy down the worksheet. You could, in your neatest possible handwriting, you can write all this down on a notebook and then you could photograph it and upload it. Another option is you can write on top of this. You can actually open this up in a Microsoft Word document, but when you do math, I want to require you guys to use an equation editor, and I want to show you what I mean by that. If you're going to type up work for me, fine, that's cool, but I don't want to see stuff like this, 2 times 10 to the power of 2. That's not how math should look for me. I can't actually grade that. It's too confusing. You've got to use your Microsoft equation editor. And the way you do that is in Word, you can go to Insert, you can insert an equation, and you can use all the proper tools here, right? So here's me doing 2 times 10 to the 2. 2, I've got a little times key up here. I've got a power key. I don't know what you guys know anymore because I'm getting too old. I have no idea what you guys learn in high school or college. So if you can handle this, then you can use Microsoft Word and type up your stuff. Otherwise, you should probably copy it down by pen and paper and write it out. Does everyone understand what I'm saying there? Things have to be formatted and look a certain, and the reason why is I need to be able to read your work and understand what you're doing. Okay.
I have a question.
Yes. Hit me.
So if you took a picture of it and you uploaded it, you have to have like a certain app to do that on your phone?
No, you can just use your camera app. But here's the thing. I know a lot of you guys out there have iPhones. I've got an old iPhone 5, so my pictures are naturally stored as JPEGs. But if you guys have one of these modern iPhones, they store it in this really complicated file system called HEIC, which I can't read. So I'm going to have to teach you guys at the end of class today how to go into your camera settings. And in your camera settings, you can choose a button that says most compatible format. And that will allow you to photograph as a JPEG. And I can read that. However, Cara Jo, if you want to use a particular app, there's one that I like called Cam Scanner. And that one's pretty dope. I don't know if Arunsak, do you know about this, about Cam Scanner? When you take a photo with your camera, it'll turn it into a PDF, which is, PDF is beautiful for me. My point, guys, is you can't just send me any old crazy crap and expect me to be able to read it. There are certain file formats I'm going to need, and we're going to all have to work together to get that right. Okay, so that was a bit about the mechanics of how we submit assignments. At the end of lab today, we'll have a session where we all try submitting things, and I'll go through and I'll say, yes, Emily, I like it. No, Eric, I don't like it. And that's how we're going to figure this out. You also earn points by doing homework with me. Homework is a really, really important part of this class. Every week, you have 5 homework problems that we have to do together, and they're complicated. They're what we would call a problem set. Let's take a look at this document that I gave you here. This is our class schedule, and it's maybe the most important document you'll get from me all semester. It has our entire semester laid out in a grid so you can follow along with what's happening. Today is Tuesday, September 1st. Our lecture is on numbers and space. We're going to do an intro. We're going to do some scientific notation. We're going to be covering stuff from chapter 1 and 2. The lab today will be measurements and powers of 10. And on Thursday, we will be doing this homework assignment. 2 problems from chapter 1 and 3 problems from chapter 2. Let's talk about the book. The book for the course is The Cosmic Perspective, the 9th edition. This is the complete text, which has both of my classes contained in it.
Mr. Burton.
Yeah?
Do you want me to send it through? I still have the digital copy as well, in case they wanted to get that one instead.
You mean like you just have the digital copy? And
yeah, I still have it from last...
I didn't see that. I didn't hear it. Okay. I didn't say that, but yes. Steal from those publishers. Okay, anyways, well, who was that? Anyways, this is, if you are an honest person, you could also purchase Stars, Galaxies, and Cosmology component. This is the half version that covers the portion of our course. So if you're going, don't get the one that says the solar system. This is the half version that says Stars, Galaxies, and Cosmology. Chris, I think there's a file sharing system through chat if you want to do that. That's great, okay? Life is hard.
Wait, someone knows how to get it for free?
I didn't say that. I don't know what you're talking about.
Of course, Professor, but you know, if somebody does,
what you guys do in the shadows is your own affair, okay? But one way or another, get your hands on a copy of that book. Get your red hot on a copy of that book. And by the way, even if you have trouble with the book, you'll notice that in the homework tab, not only have I listed the assignments, so I'm sharing my screen here. Let's go back to Blackboard. You'll notice something else, Chris, that on your homework tab, this is the homework assignment that we're going to be doing on Thursday. I actually scanned in the pages that have the questions that we're going to be working on. So the first question that we have to do is from chapter 1, number 42. And it's called Scaling the Local Group of Galaxies. Even if you don't have your textbook yet, you should. By the way, this is one of the reasons why we're going to do our homework together. So that I'm going to ask you guys to read the questions and we're going to talk our way through it. And I have very particular things that I want from you. And by doing the homework together, we'll make sure that you guys satisfy my requirements for what I consider to be a good homework. Believe it or not, doing the homework together, you actually learn so much more than if you did it on your own. And it's more fun and it's faster and then your grade goes up, and you just happiness and joy abound. So it's very important that you attend these office hour sessions on Thursday. Note for the night class students, they will be watching the video as a pre-recorded video, and I will record not only the lectures, but I will record the labs and the homework sessions. So if you ever, God forbid, if you get sick in these troubled times or something, you should be able to watch the recordings afterwards and get the work done. There's no reason to not get your work done in this format. Kara.
I'm supposed to be like a night student. Is this like,
that's
it's
great.
Okay for me to attend during the day?
That's exactly what I was hoping, Kara. If for anyone else out there in the audience who's part of the night class, I didn't want to have to repeat myself and give this lecture twice in the same day because it would make me crazy. And there's no reason that we can't have the night students who are available come join us. You're basically all part of Astronomy 1020, whether you're in section 01, 02, or 101, you're all part of the same family now. So Kara, if for some reason, I think most of your compatriots in the night class, a lot of them have some kind of job during the day where they can't watch this. So they're gonna watch the pre-recorded versions. But of course, it's way cooler if you can attend live because then we can talk to each other. It makes the class better for everyone. But yeah, Kara, keep doing this, okay? All right, but anyways, we'll talk more about the postings, the videos later. There's only two other ways to earn points in this class, okay? And the other two places to earn points besides homework and besides lab are two big scary tests, okay? There's going to be a midterm and there's going to be a final exam, a big scary test that will be a little stressful, but there's only going to be two of them. And if you've attended your labs and if you've attended and completed your homeworks, that will have trained you for the exams. Another good thing is if your scores are high enough in homeworks and labs, if you do all your homeworks and labs, it is virtually impossible to fail this course, even if you do bad on the exams. So that's one reason that you want to make sure that you're always turning in your homework in your lab, because it will protect you and make sure that you pass the class no matter what. I'm talking like C or better. The only way you can really screw this class up is if you are a flake and you don't turn in homeworks and labs. So just don't be a flake, okay? Don't flake out and not turn stuff in. There's no reason for it. We're gonna do it all together. And that's great. You're not gonna have to take home some like giant midterm and work for hours on your own. We're gonna do this all together, and then when you close the laptop, it's gonna be over, all right? Let me just check the chat log to see how people, oh, okay. All right, that's great. Thank God I'm not an art teacher. I don't have to look at your crappy little sculpture at the end of the semester and say B-. Like that's not how it works here, guys. Your grade is a number. I built the Candyland, and you got to move your piece around and earn some points. And my job is to help you earn those points and to put them into the little slots here. And then I push the button and whoop, out comes your grade. If you do your homeworks and you do your labs, you are guaranteed to have a great time in this course and pass it no matter what. All right, so low stress, high fun. Okay, do you guys have any questions about that?
I was wondering if Chris had any textbooks for other classes.
Why don't you guys work that out offline? Okay?
Maybe. You gotta ask me which one did.
I'm gonna be known as a clearinghouse for the illicit PDF trades or something, which wouldn't be the worst thing I was ever, called. So, okay. Guys, if you have noticed what we've done so far, I have provided you with a Roman numeral style outline of the things that we're gonna talk about. And if you go to Blackboard, like I said before, if you go to your lecture notes section, I provide you with lecture notes of the things we're gonna cover during our classes. You just had lecture 0, which is an introduction to Astronomy 1020. That's where I talk about what we're gonna learn and the rules of the road for our class. These aren't all-inclusive study guides. They're just a little top-down view of the things I wanna talk about. We are now gonna launch ourselves into lecture 1. Shoot, where is that here? We're gonna launch ourselves into lecture 1, which is numbers in the nighttime sky. One of the reasons it might be useful to save these or to print them out even, I think if you do have a printer, you'll discover that these handouts are useful because they have like numbers and conversion factors that you might need during the course of the year. So I tried to provide you with some useful stuff, and this is what we're going to be talking about. So just mentioning that if you want to keep track of the game here. All right, so let's go ahead and let's start our lecture proper. Oh, unless there's any other questions. It doesn't seem like it. Let's take a look at our first slideshow. By the way, I've also included my PowerPoints on Blackboard, so if you ever want to look at them on your own, you can. I'm starting off by showing you a field of stars. Let's show you some other famous stars here. Hold on. Do you guys know what this is? What are we looking at?
Orion's belt.
We ain't just looking at Orion's belt, son. We're looking at the whole damn constellation, right? Orion's belt is here, so yes, these are the 3 stars that make up Orion's belt. But we also see his shoulder blades. This is the great star Betelgeuse. Do you see this red star Betelgeuse? One of the most famous stars in the nighttime sky. In your first homework assignment on Thursday, our job is going to be to calculate the diameter of the star Betelgeuse. You don't know how to do that yet. I'm going to have to train you on that, okay? He's got 2 shoulders. He's got 2 feet. This is the blue star Rigel down here. He's holding a bow or sometimes a bobcat, and he's got a club. You can't see Orion every single night. There are certain times of the year where Orion is visible and certain times of the year where Orion is not up. And usually you see Orion during the late autumn and the winter time and even a teensy bit into spring. Learning how the nighttime sky works is interesting and it's complicated. And we're going to need to build up some common vocabulary terms so that I can start to teach you how to talk about stars intelligently and how to recognize when certain stars will be up in your nighttime sky. I'm going to try to keep track of the chat room here, but bear with me. Okay, so to do that, I need to teach you guys a little bit about where you are. Here's the legendary Pioneer plaque. This plaque was placed on the Pioneer spacecraft, the first man-made object to leave our solar system. The scientist who built it thought, well, if we're going to have a spacecraft that leaves the solar system, there's always the possibility that one day in the future, aliens might find it, and they might wonder who built this thing. And they left a little pictographic record of human beings in relationship to the wing of the spacecraft, and they show the satellite coming from the 3rd planet from the sun. It's kind of like a little roadmap of where you are in the universe. They even explained how to find the sun relative to a number of well-known pulsars. Basically, this could be construed as a come here and eat me roadmap to taking over the human race, okay? Anyways, sometimes it's good to know where you are and how things work. So welcome to the universe. You live on planet Earth, which is one of 8 planets in our solar system. The solar system consists of the sun, 8 lovely planets, a number of dwarf planets like Ceres and Pluto and Eris. There's even some asteroids. The asteroid belt is between Mars and Jupiter, and there are some comets that are outside the orbit of Neptune. And that's pretty much our solar system, the sun, the planets, and some small miscellaneous debris. What if I leave the solar system? Where am I then? What's outside of the solar system? This is, I'm asking you because I don't know if I'm telling you obvious stuff. Wyatt, what do you think?
Kuiper belt.
The Kuiper belt is that range of realm of comets, Wyatt, that I was talking about out here. So the Kuiper belt technically is part of our solar system. I'm thinking if you zoom out from there, what's the chat say? The galaxy, Arunsak says. Yes, what's the name of our galaxy? Do you know?
The Milky Way?
Yes. If you were to zoom out from our solar system, you would see that you were part of a vast assemblage of stars and their planets, as well as what makes a galaxy different than solar systems is that galaxies contain tremendous quantities of gas. So the Milky Way is a swirling disk of hydrogen gas, plus stars and their planets. Our galaxy, the Milky Way, is just one of a great number of galaxies which exist in our universe. The universe might be thought of as all the galaxies together. There's a lot of stars in the Milky Way galaxy. One estimate is up to 1 trillion stars. Do you guys have any idea how big that number is? Do you know what 1 trillion means? How about how many zeros are in 1 trillion? See, these are, Austin, that's okay if you don't know, but these are things that we got to learn if I'm going to have an intelligent conversation with you. 12, says Kevin, and correct you are. Let's take some notes. It's time for y'all to learn something.
Is it 1,000 billions?
It's 1,000 million. That's one way to, no, sorry, that's a billion. Look, we got to get this.
No, I said 1,000 billions.
Oh, yes, it is 1,000 billions, but that's, while that is correct, that's maybe not the most efficient way to say it. Let's learn some stuff about big numbers. Because astronomy deals with the world of the insanely big and the insanely small, we're going to need some intelligent ways to talk about big numbers. And that's your first lesson for the class. Lesson number 1 is on something called scientific notation. With so many students taking the course, I'm guessing that a few of you out there have seen this before, but guess what? You're going to see it again because it's important, okay? And as a gateway drug into learning about scientific notation, we could start by considering or contemplating the number of stars in the Milky Way galaxy. Which is approximately 1 trillion stars. Kevin reminds us that 1 trillion is 12 zeros, so we will write that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stars. That's a big number. And yet, even though it's a big number compared to like your bank account, it's a relatively small number in astronomy. I want to show you guys something here with your Casio calculators. Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's it. What that means to me is that your Casio calculator is capable of holding 10 decimal places. But the number trillion is 13 digits long. So you couldn't put that number into this calculator, and yet we're going to need to put this number into the calculator. This number is too long for us to deal with it in the normal way. We're going to need a compact way of expressing big numbers like this. And to do that, we're going to borrow some concepts from our math class. We're going to talk about powers of 10 here for a second. Let's review something you might have learned at some point. If I take 10 and I raise it to the power of 1, that's like taking 110 and multiplying it by 1, which is 10. If I say 10 squared, that's 10 times 10, which is 100. If I take 10 and I cube it, that's 10 times 10 times 10, which is 1,000. Now, I'm starting to see a pattern develop here. Anytime I raise 10 to some power, I get a 1 followed by that number of zeros. So for instance, 10 to the power of 4 is 10,000. It's a 1 followed by 4 zeros. 10 to the power of 5 is 100,000. That's a 1 followed by 5 zeros. Okay, you guys try it. What's 10 to the power of 0?
1.
Very good. Who said that? Who knew? Ah, Wyatt. I can't fool Wyatt. 10 to the power of 0 is 1 because if you multiply 0 tens by 1, the 1 is left over behind, okay? people think that 0 is the default number, but in Algebra 1 is the default number, okay? So by definition, any number raised to the power of 0 is 1. And that's going to be helpful for us because we can use these powers of 10 to compact this long number into a form called scientific notation. Let's first diagram our number and learn about the different parts, okay? The first number in your number is called the lead digit. The lead digit is the first number in your number as long as it's not 0. 0 cannot be a lead digit. Has to be 1 through 9. Then you have the number of zeros. The number of zeros is what a sophisticated scientist would call the order of magnitude. Okay, that's what we call this. The order of magnitude expresses the general size of your number. Is your number a number of order hundreds or thousands or millions or billions? That concept is the order of magnitude. It's roughly how big is your number. And then last but not least, we have the tag called the unit. Units are of extreme importance in scientific thinking. And the reason why is that all numbers, every number you've ever encountered in your life, whether it's the number of dollars in your bank account or the number of teeth in your head, they are all measurements. And you have to know what units you are measuring things in. Otherwise, you don't know what you're talking about. When we do homework, when we do labs together, I will always expect you to put units down with your answers. That's going to be a very big personal thing for me, okay? And you will have to do it. So let's look at how we're going to compact this number using scientific notation. I'm going to do it up here so I don't lose any board space. Okay, we start with our lead digit and we write that down. Then we look at our number of zeros. There are 12 zeros. So that would mean 10 to the power of 12. This tells you how many zeros are in your number. And then I keep my units there, stars. That's how we write the number 1 trillion in scientific notation. It looks like a math problem, but you should not think of it as a math problem. You should think of it as a weird way of expressing the number 1 trillion. This is so important to us that we're going to learn that there's a special key on your calculator that lets you put numbers into scientific notation. Let me introduce you to that key. That key is your EXP key. Your EXP key is the single most important key you will learn all semester. It means times 10. So this is what you're going to write on your paper, but what you are going to type into your calculator is 1 EXP 12. If you have your Casio, punch after me, okay? Just do 1, oops, sorry, clear that out. Do 1 EXP 12. And that's what you see. You don't even have to hit equals, okay? When you punch 1 EXP 12, remember class that EXP means times 10, okay? That's very important. There's no more typing times 10 in this class. It's just EXP. On your display, you're going to see 1 with a little 12 after it. And that's because space is so precious on this calculator, they don't have room to put in the times 10, okay? So this is what you see on the display. However, when it is time to write down your answer, when it's time to write this onto a piece of paper, you will write out the number in this form, 1 times 10 to the 12. You will not write 1 EXP 12 And God forbid if you write 1 to the power of 12. That's going to really tick me off. Because students, if I write this down on a piece of paper as math, remember what that means. That 1 to the power of 12 means 1 times 1 times 1 times 1 times 1, 12 times, right? And what's the answer to that math problem? Right, Arunsak, it's 1. So if you write this on your paper and you're thinking it means 1 trillion, I'm going to look at that and I'm going to think it means 1 because I speak math. And you are obligated to speak math as well. So you type this, you type 1 EXP12, you see this on your display, but then that's what you write down on the paper. I hope that's clear to you guys. This is so important that our first lab today, which we're going to do in a few moments from now, is just going to be us practicing using the EXP key on our calculator, and it's going to be us practicing multiplying numbers in scientific notation. You need this skill. You cannot even take one tiptoe into the cosmos with me unless you are capable of punching in numbers in scientific notation, okay? Maybe not the most exciting stuff you've ever learned, but really useful. That means, class, I want you to think about this. If you have your Casio calculator today, you're going to be up and running and you're going to be learning stuff. But if you don't have your Casio calculator, you're still going to have to try, but it's going to be ugly, okay? I recommend, if you don't have a Casio calculator, just get any old piece of crap that you can find. Unfortunately, calculators like this, they're not, we kind of need a few scientific buttons, you know? So like, you're gonna have to, there's an app on the iPhone that I think is not horrible. It's called PanEcal. I don't really like it, but it has a calculator that's kind of similar to the Casio FX260. It's not exactly. If you go to your app store, where do I have it? If you have a Google phone, I don't know. I only have an iPhone, so that's what I know how to do. But in the app store, I was trying to find another one. This is not going to cut it for the semester, but just for today, PanEcal.
Are we gonna have to show our work on our papers?
Hell yeah! What do you think this is, amateur hour? Of course you're gonna have to show your work. Listen, the thing is, you have to learn how to show your work. You have to learn what I want to see. It's not going to be obvious to you. But whoever said that, I don't know if you were a troll or what, but the reason why you don't have to worry is we're going to do it together. And I'm going to show you exactly what I want. Your hands don't go on the steering wheel, okay? I'm driving this bus and you are all passengers. So buckle up your seats, we're going for a ride. I'm gonna tell you exactly what I want you to see and when to see it. So it's gonna be cool, but can I tell you something? Let me just wax philosophical about this whole Zoom thing. When I could see you guys in person in a classroom, I could walk around and I could terrorize you and I could look at your papers and say, what the crap is this? What kind of garbage is this? I would fire you if you were my employee. But I can't do that because you're all hiding in your little bedrooms there. You know, you're eating Cheerios, whatnot. But you have to ask yourself this question. Do you want to learn? Do you want to come out of this class stronger than you went into it? I think most people, the answer to that is yes. But you're going to have to push the buttons with me, okay? If you want to slack, if you want to be a slacker and just write, you can do that. I'm not going to catch you, okay? You can totally skim your way through this thing. But I don't think that's how you are. I think you're going to want to learn and you're going to want to come out of the stronger. All of the students who've taken my class, they have improved math skills and they're able to do things they weren't able to do before and they like it. They like that feeling. So I want you guys to have that same experience. Point being, get the dumb calculator so that we can do work together, okay? Now look, before we do our lab, we're gonna try one more example so that you guys get the flavor of the feeling here, okay? 1 trillion is an easy number to put into scientific notation. Let's look at one more annoying number to see how it's done. Okay. Let's say you had an annoying number that you had to put into scientific notation. And that number was 98765432110. Now, if you guys remember how this works, if the decimal point is over here, I can put a comma after every 3 numbers to kind of keep my brain straight here, right? So put a comma there, there, and there. Does anyone out there in the audience know how to read this number in English? Like, how would I say that number? I'm not sure if you guys can do that. I don't know what you can do.
9,876,543,210.
Beautiful. Okay, just like that. So this is the hundreds, thousands, millions, and billions place. I'll give you a cheat sheet on that in a moment. Now, the reason why this number is more difficult than the previous one is we don't have a whole bunch of zeros, but we do have a lead digit. What's our lead digit? Y'all know what it is.
9.
9. All right. So we write down our lead digit. We put a decimal point after it. And after the decimal point, we can keep some of these other numbers as change, okay? So we can write 9.8765432. We don't need to write the 0. Now we're going to multiply it by 10. And we're going to treat all the other numbers that weren't the lead digit and pretend like they're zeros, okay? Another way to think about this is the decimal point starts here. That's where it starts. And the decimal point has moved over to here. That's where it ends. So we can count the number of times that the decimal place has moved. It's moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And that's my power. 9.8765432 times 10 to the power of 9. If you were a pesky student, you could say, bro, look at this. This looks way worse than your original number. Why did you make me do this when the end product looks even yuckier than the initial thing? Okay, fine, you got me. But you're missing the point. In a scientific notation number, this number here is the order of magnitude. That tells you roughly how big the number is. But this part of the number here is what we call in science, this part of the number is the precision. And the precision tells you the quality of the measurement, how carefully it was done. In science, and especially in astronomy, which is a low precision science, we usually don't need to keep all of these numbers. They're not necessary. So what we can do is we can round our number off. And when in doubt, if you don't know what you're doing, you keep 2 significant figures in this class. That means you keep the lead digit and you keep 1 digit after it. So if I'm going to chop my number there, I have to use good rounding rules. And I think you guys remember what the rounding rules are, right? If the first number that you're going to chop off is less than 5, you leave it as an 8. If this number is 5 or more, you increment to a 9. So since I have a 7, I would round this number off as 9.9 times 10 to the 9. Or in other words, this number is essentially 9.9 billion. That's how we do numbers in scientific notation. We put them into scientific notation and we round them off to 2 digits, okay? That's how we're going to do things in this class. From now on, class, we are going to have a rule in this course. This is now our class rule, okay? And that's any number which is greater than 1 million must be put into scientific notation. So I will allow you to write down the number 999,999, but as soon as it crosses into 1 million, I demand scientific notation, okay? I demand it.
Excuse me, are we allowed to use scientific notation for numbers less than 1 million still? Is that still okay?
Well, You are, but it's kind of like good taste, right? You have to learn good taste. While you could put the number 2 into scientific notation, and in fact, in our first lab, I'm going to ask you to do that just as a kind of exercise. In general, if you put the number 25 into scientific notation, it's a little bit like, it's kind of Rain Man-like, you know what I mean? Not wrong, but just goofy and awkward. And we would like to not be awkward. We would like to be smooth. So from time to time, it might actually make sense to do it, and I'll allow it. But I might also start doing it back to you. You know, like I might decide to grade your paper 25 out of 25, and I might start writing stuff like 0.25 times 10 to the 2. So if you want me to start talking, if you want to start talking to me like that, then you better expect me to start doing some passive aggressive shit back to you. Okay, so in general, I would probably recommend that you refrain, but use the force, Luke. Okay, you'll know when it's right to use scientific notation. I hope you will, anyways. Let me have you, before we end our class and go to lab, let me have you guys, I'm going to make a useful chart. Now, I want to say something, kids. When you go to the store to get your calculator, I'd strongly recommend for this course that you invest in a 25-cent jobby ruler at Joblot or something. Make sure it's got metric centimeters on it. Having a little ruler like this around your house, it's less than $1. And I love to make tables in the notes, so that'll be helpful for making tables and things. I want to make a quick table with you that I think will be useful during the course of this class. And it's just to keep your brain straight between millions and billions and trillions and things, okay? So make a little table with me. This will be our last note for the day. We're going to have 3 columns. The first column will be for the name of the number. The second column will be the number of zeros, 10 to the power of x. And the third column will be the metric prefix, okay? And we're not gonna do all the numbers. We're just gonna do trillions and billions and millions and thousands. And I'm pretty sure this is gonna come in handy, okay? Because I've done this before. So here's a trillion. Here's a billion, a million, and 1,000, all right? So you guys have learned that a trillion is 12 zeros, 10 to the power of 12. How many zeros are in a billion?
9.
10 to the power of 9. How about a million?
6.
Good. And then most of you know that 1,000 has 3 zeros. Most of you. But hey, I don't assume anything. You know, one of the things about community college is people come to these courses from a huge variety of backgrounds. So if you're one of those people hiding in the shadows that just has never even looked at a number before, that's cool. This is a place to learn that stuff, all right? There are metric prefixes that we can use for these numbers of zeros. For instance, you may have heard of a kilo before. A kilo is the metric prefix for 1,000. A kilometer is 1,000 meters. A kilogram, which I have here in my hand, you can see a kilogram is 1,000, well, it's upside down. So a kilogram is 1,000 grams, okay? What's the metric prefix for million? I bet somebody knows.
Mega.
That's right. A megabyte is 1,000,000 bytes. How about a billion?
Giga.
Giga? How about a trillion?
Tera.
Tera. A terabyte is 1,000,000,000,000 bytes. Whoever said that, what if I said 10 to the power of 15? Do you know what 10 to the power of 15 is? The metric prefix?
No.
It's a peta.
Zeta?
Peta, P-E-T-A. I think the internet is supposed to contain something like, I don't know, several petabytes of information.
Damn.
Actually, that number has probably grown since the last time I looked. I wonder if we could look this up. This is just me goofing off. I like to do this.
I'm sure it's growing like exponentially.
Yeah.
Professor, do I have enough time to go to the store and get the calculator?
No, you don't, because we're going to do our lab nice and quick in just a few seconds. I feel your pain, my friend, but listen, can you find some phone calculator or something to use in the meantime? It'll be fine. Just get the calculator for next class, okay? I know it's going to suck this first day, but I expected that. Now I'm kind of curious, just for my own personal edification, how many petabytes are in the internet? Number of petabytes. I don't even know if this is something that will... Oh, wow.
Wow.
So
what would
Google,
that be?
Amazon, Microsoft collectively store 1,200 petabytes of information. That's not even including Dropbox. Wow. That's wild.
What would 18 zeros be?
We're going to actually use big numbers like that all the time in this class, but I have to admit, I start forgetting some of the names. So there's a really killer Wikipedia page that you and I are going to use all the time called The Names of Large Numbers. And the thing that makes it confusing is there's ones for American English and ones for British English, and they're not the same. So like in the United States, 10 to the 18 is a quintillion. And there is a metric prefix for it, I'm sure, but I don't know what it is. You guys can help me by Google checking me while I'm giving the lecture, so you can tell me what those things are. I know 10 to the 15 is a petabyte, but I don't know.
Yeah, 10 to the 18 is an exabyte.
Exobyte, that's right. I've heard of that.
Yeah.
Man, an exobyte. That makes me like hungry for a sandwich or something. Anyways, so guys, this concludes our lecture portion of the class, and it's now time for us to do a quick and hasty lab. So let's take a trip over to our lab room where we're actually going to do some stuff together. And I'm going to march you guys over here through my messy apartment loft and grab a calculator and a ruler. Just a moment, folks. Okay, here's what we do need to work out. How many of you actually, I should have told you to do this earlier. How many of you actually printed out today's lab here? Did you do that? So, okay, Stacy did. Wyatt did. You guys are smart. No, Kaitlyn. Kaitlyn, do you have a printer? Okay.
I can probably find one though.
No. Is that Aaliyah? Can you help me with your name? Is it Aaliyah?
Aaliyah.
Aaliyah. Okay. Aaliyah, did you say you do or you don't have a printer?
I do. I just need to buy ink and paper.
Oh, okay. Okay, here's what you're going to do today, Aaliyah. If I'm saying that right, please correct me if I mangle your name, okay?
Yeah, that's right.
If you don't have a printer today, luckily today's lab is wicked simple. All you need to do is just kind of write down in your notebooks the numbers, because basically we're just going to do like 1 or 2 pages of this, and it's just like writing down a couple of math problems. So what you guys are going to do, Kaitlyn, Aaliyah, anyone else who doesn't have a printer handy, you're just going to write out the problems that we do, and then you're going to submit that. In the future, however, can I tell you, when the labs get a teensy bit more complicated, they'll be more annoying to write out. So let me tell you what you can do, Kaitlyn and Aaliyah, if you don't get ink from Staples or whatever. In addition to printing, another option is to convert it to a document and type the stuff in. And let me show you guys how that might work. You guys may not realize this. It took me a while to figure it out. But if you go to your CCRI email, do you guys see the 9 dots that are in the corner here? Well, a student showed this to me last semester. You can click the 9 dots and you can get basically web applications of all of these different Google apps. So you can open up Word, and I think you can actually open up the file in Word. Now, I actually have, I believe I tried to, once I realized this was an issue, I started trying to convert the labs into document form too. Let me see if I have a document for powers. I do. Let me see if I can chat this to the whole class here. I'm going to try, just like Chris shared a file with you. I hope this works. Oh my God. I can't even send you guys a file. Chris, how did you do that? I think they took it away from me.
So when I sent through it, it just was doing the loading, and it was just loading for a while until finally it went through, but I just hit add file.
I used to be able to send you guys a file through chat, but now that I've logged into the CCRI system, everything is so much worse. I can't tell you how. All right, I'm complaining right now, but let me see if I can share a file with you. I don't even know how this would work here. Okay. God damn it. They messed this thing all up on me here. Share file. How did you do it, Chris?
When I opened up my chat, there's a little file next to like the tag for either talking to everyone or just through privately. And I hit that and it just brought me up to my files.
Right. But my question is, why is it deactivated for me?
Because you're signed into CCRI. That's the only reason.
That's exactly right.
I am not signed into CCRI right now.
You know what I'm doing the second I get off this computer today? I'm calling them up and I'm getting off this bloody system. I'm so angry about it. Okay, well, hey, I'll tell you what. I can email you guys the .word file. I don't even know if anyone cares, but because there's so many of you, everybody's going to want to try to have a different approach here, and we all have to kind of be on the same page somewhat. Let me send an email to the class. That's one way I can do it. And this is lab 1, powers of 10 as a document. And I can attach the file. Come on, baby. Come on, baby. Let's do this. Okay. Sorry, it's the first day, so there's going to be some weirdness as I get used to this new system here. Send it without a message. Yes. Okay. If anyone is interested in the document version, I sent that to you. But my point is, probably Aaliyah and Kaitlyn and a few others, you might want to just copy down the math problems by hand. It's going to be simpler that way. But the reason why I showed that to you is in the future, we might want to make use of some of these more elaborate processes to get because some of the labs are a little more involved, okay? Okay. Here's what I need you guys to do for me to start off. Let me get my my phone. I'm going to use a feature from Zoom that allows me to turn my cell phone into, where am I here? Oh, sorry. I'm going to use a feature that allows me to turn my cell phone into a little portable camera so that we can do work together. Now that's a pretty cool feature. What does happen though is sometimes people will chat me and be like, hey, let's get some martinis or something. So you're going to see occasional embarrassing pop-ups from my personal life show up. Try not to hold it against me, okay? But it's too good a feature for us to not use. Let's try it now. I need to be connected to Wi-Fi for this to work. Sometimes it works flawlessly and sometimes it works not so great. I'm going to share screen. That's okay, Devlin, no problem. Let's share our screen, share my iPhone, and let's see, a plugin has to be installed. Okay, install the plugin. All right, and I'm gonna go to screen mirroring, and there I am, boom. Yeah, okay. You guys can see my phone now, correct?
That's crazy.
And watch this, boom. Now I've got a little portable camera. You can see all around my world with me, okay? All right, here's what I want you guys to do. First of all, I like to work in pencil because it looks better when you erase it. When you work in pen, you tend to scratch things out, and that's no good. So make sure you got a pencil there. Okay. And now let's come over here, and I'm gonna use this tape. Let me get myself onto the, yeah, you guys watch this. You can see I've got a roll of tape here. Now, the first thing that I need you guys to do is I need you to put your name, okay, on the top. And I need you to put your lab section. I want you to write AS1020. And then whatever your section is, so if you're in section 001, put 001. If you're in section 002, put that. That's technically the Thursday lab. Kara, you're in the night class, right? Kara Jo?
Yeah.
So you could either put
on Tuesdays, night class.
101, or you could just put, for the night students, just put, just put 1020 night, okay? If you're in the night class. But if you're in the day class, put 001. Do you guys know what section you are? Hey, you guys can't understand how important this is to me. I have 150 students this semester, right? So when you guys write me an email and say, hey, B, it's Kevin, I'm in your class, my first thought is, what fucking class? I have 6 of them, right? What you should say instead is you should say, hey, B, it's Kevin, I'm in AS1020 section. What's your section, Kevin? 00. Do you know what your section is? I need you guys to know your section. You're in section 001. So Kevin, if you ever wrote me an email, you would say, hey, it's Kevin from AS1020-001, right?
Yeah, I'm in the night one.
Oh, you're in the night class?
Yeah.
That's section 101, or you should put AS1020 night. That's fine, okay? But do you guys see what I mean? I need you to tell me those things when we talk to each other. Okay, so back to the show here.
Professor, should we be doing this on like the Word doc, or would you recommend writing it down for them?
I think today, Austin, to keep it simple, why don't you write it down? If you have a notebook or something, or a piece of paper, we can do the work here, but you're gonna have to copy these problems down, which shouldn't be too intensive. 1A is 2.0 times 2.8. You see what I mean?
Yeah.
So what do you think, Austin? I think rather than fiddling with the computer, just doing it by hand and then we'll photograph it, okay? Keep it simple.
Love it.
Class, what is the purpose of our first lab today? The purpose is nothing more than practicing using your EXP key and practicing using scientific notation so that I know you can handle it, okay? All I want us to do is, I don't want us to follow the instructions. No, 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 we're not gonna do that. We're just gonna practice using the EXP key. Now, if you have your Casio, punch along with me, okay? Our goal is to get our final answer. Every single answer today will be in scientific notation format. Okay? Even if it's the number 2, we're going to put it into scientific notation. So our first problem is to do 2.0 times 2.8 times 10 to the 5. And wherever we see times 10, we're going to use the EXP key. So punch along with me. 2.0 times 2.8, and then I'm going to hit EXP 5, and then hit equals. What do you see?
560,000.
Very good. Who said that? I want to just try to call you guys by name. Oh, is it Kaitlyn? Thank you. Sorry, I was looking down. Kaitlyn, although if this was a homework, we would not need to put that into scientific notation, today we want all of our answers to be in proper form of scientific notation. So can you help me put that into scientific notation, please? I think you can. No, don't freak out here. What's your lead digit?
5.
So let's write down 5, okay? Put a decimal point after it. And then we should keep the 6 as change, right? Okay. Now we do times 10, because it's always times 10. And how many times did you move the decimal place?
5 places.
2, 3, 4, 5. That's right. So that's your power. And when you're done, box it, because that's a classy move. Boxing it helps your instructor know this is what I think my final answer is. We'll get in the habit of doing that. Okay. Everyone cool? That's what I should see on your page right there. We want to get the answer right into scientific notation format. Let's try another one. Oh, can we talk about the negatives for a second here? Let's have a little breakout sesh on powers of -10. This is another learning skill that we need to have. Okay. We can use powers of -10 to represent tiny numbers. Like, consider this number, 0.000234. That's an annoying number. That's a number that's too small for me to want to see on your page. We can use powers of -10 to represent this number, okay? For instance, suppose I take 10 and I raise it to the -1st power. What that means in math, oops, I lost you guys for a second here. I need to go into my settings and I need to fix the timeout on the display. Display, auto lock, never. Okay, 10 to the power of -1 is the same thing as saying 1 over 10 to the power of 1, right? Negative powers are not negative numbers. Negative powers are small numbers. It means 1 over 10 to the power of +1, which is 1/10. And 1/10 as a decimal is 0.1. Likewise, 10 to the power of -2, that's 1 over 10 squared, which is 1/100th. 1/100th as a decimal is 0.01, excuse me, okay? And then 10 to the -3, that's 1 part in 1,000, which is 0.001. Do you guys see what's happening here? Every time I raise 10 to another negative power, I basically move the decimal place over another place to the left, okay? So let's look at 0.000234. What is my lead digit in this number? What's the lead digit?
2?
That's right.
4.
No, it's the first number, the leftmost number in your number that is not 0. So it's 2.34 times 10. And now we have to count how many decimal places we moved. We moved -1, -2, -3, and that's where we stopped, -4 there. So this is 2.34 times 10 to the -4. That's how we use negative powers. Now, you will not use the minus key. You will use the negative key, which is located just above the 7 here, okay? Let's look at our next problem. 5.6 times 6.725 times 10 to the -6. Okay, so we do 5.6 times 6.725 exp negative key 6. And then we hit equals. Is that what you see in your calculator? Okay, good. That means you're doing it right. Kara Jo, because I can see your face now in my little window. How should I write this down here? This is important. How do I transcribe this onto the page?
So it would be 3.7? Oh God, times 10 over 5?
Not 10 over 5.
Or
10 to the -5. My only point, Kara, is I wanted you to put the times 10 back in there, okay?
Yeah, yeah.
So we would write this as 3.766.
Oh, okay.
times 10, sorry, times 10 to the negative 5, right? That's the format. That's what I wanted to make sure that you were going to put the times 10 back in there, right? Okay.
So I have a quick question.
Yeah.
So how many decimal places are you going to want us to add? Because you get a lot down the line in these problems.
Exactly, Wyatt. In fact, Wyatt, believe it or not, you just opened up a whole can of whoop ass there, okay? That's a whole discussion. That has to do with precision, and precision has to do with measurement. My goal today, Wyatt, with the short time we have to get together, was actually to teach you two things. One is to just teach you how to use the EXP key and to make sure you can handle putting numbers into scientific notation, right? But then once I think that you've mastered that, I want to actually have an adult conversation with you about the art of measurement. And the art of measurement is related to your question about how many decimal places to keep. Wyatt, for now, could we just make up a loosey-goosey rule in this class is if you're ever in doubt, round to 2 significant figures. So what would this be if you rounded it to 2 sig figs?
3.77.
No, that's 3 sig figs. See, we have to have a talk about the sig figs. You guys are like babes in the woods. You don't know anything, all right? You're not even ready to have that discussion yet. You'd round it to 3.8.
Okay.
Times 10 to the minus 5. We're going to talk about that later on down the line. One thing at a time, Wyatt. Let's just make sure we can do the scientific notation. Okay, guys, let's punch that into the calcies. See if you can do this one without me. Punch 3.77 EXP5 times 4.8 EXP3. Now, I want you guys to learn some etiquette with me. Here's how you're going to prove to me that you're punching correctly. When you punch it, I want you guys to get in the habit of putting up your thing, just like I'm doing, to your camera. And I'm going to walk around the classroom, so to speak. Yes, Kaitlyn, you've got it. You did it right. Who else has got something for me? Yes, Austin, I like it. This is going to help you get some feedback. A Ty, that looks good. Donovan, that looks great. If you don't have your calculator today, all right, but get it in the future. Tifany, I like what I see there. Does anybody else? Cole, didn't I see? Show me what you got, Cole. Don't be shy. Wait, Cole, didn't you have a calculator? Oh, Paul, hold that a little bit higher, Paul. Yes. Yes, Paul, that's good. Cole, I want to see what you've got there. I want to see what you're doing. That's how we make this real. Emily, I love it. Hold on, I've got to kind of click around. Arunsak, I like it. Chris, I like it. Kara Joe, I like it. So far, I've seen everyone doing it right. Anyone else out there? Cole, did you get something for me?
My calculator isn't like charged, so it just keeps turning off and I have to keep putting it back in.
It's because you're in the dark, Cole. Do you have a small lamp that you could put overhead? I like the dark too. I'm a bona fide vampire, my son. But you got to have a teeny bit of light to get that thing working. Did I see anyone else out there? Stacy, that looks good. I like it, Stacy. Okay. Let's try to get in the habit. During the course of this semester, we're going to do this thing all the time. Me keeping track of you punching, that's how I teach you stuff, okay? Okay, look at that crazy number. How are we going to put it into scientific notation? Who's brave? Who wants to try that?
1.8.
Okay.
Times 10.
Yep.
To the 9.
I like it. Let's just count those up together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. 1.8 times 10 to the 9. I like it. Let's do the next one. 5.29 EXP3 times 6.8 EXP minus 7. Okay? So 5.29 EXP3 times 6.8 EXP minus 7. That's what I got. Is that what you get? Okay, cool. All right.
Can I see the problem? Can you show me the problem again? Because I'm writing this all down by hand.
Yep. Can do.
Thank you.
Sure. Stacy, you want to give it a whack? How do I put that in a scientific notation? Well, it's already in scientific notation. Anytime you see the number up there, that means it's in scientific notation, right? So what are we going to write down on our page? I don't know. Anyone can shout it out.
Times 10 to the negative 3.
3 point what?
6.
Yeah. 3.6. That's okay, guys. We're all learning. We get this. All right, let's try to crank these out quick so I can teach you something else. 9.65 EXP3 divided by 2.0. EXP3 divided by 2.0. Okay, how do I write my answer in scientific notation?
Holy cow.
Stacy, did you say something? Oh, I didn't hear you.
Yeah, I did. Sorry.
I think, remember, there's a little delay when you hit mute. So mute, unmute, and then talk to me. So what, do you know how to put it in scientific notation?
All right, I'll try it. All right, so it would be 4.83. 4.83 times, wait, I didn't, can you, time 1, 2, 3, time 10 to the 3rd.
That's fine. You kept, by the way, for the record there, you kept 3 significant figures. That's okay though. It's not wrong. I'm okay.
Oh, okay.
We're going to learn how to choose the right number of sig figs in a moment. Let's do the next one. 5.6 EXP5 divided by 1.6 EXP5. How do I put that into scientific notation?
3.5 times 10 to the 0.
Nicely done. Who said that? Who was that?
Wyatt.
Wyatt, I like your moves.
Thank you.
10 to the 0 because you did not have to move the decimal place. You already had a good lead digit, right?
Mm-hmm.
By the way, this is what we would call in scientific notation, we call it proper form, okay? The proper form of scientific notation is when you have a single lead digit followed by some change times 10 to some power, all right? So that's what we call proper form when it looks something like that, okay? With any arbitrary number of sig figs. Let's, oops, I'm gonna run out of battery space here. Let's do the next one. 3.2 EXP9 divided by 2.4 EXP5.
I'm so lost.
Okay, let me help you. Who's lost? I want to help you.
I am absolutely lost. I have no idea what's going on.
Look, I know that's going to happen. That's fair, but I appreciate the honesty. So how do I help? So Devlin, I'm going to talk to you. And who else was lost? Was that, who else did I hear? Wait, who's me?
Carajo.
Oh, Carajo.
Carajo.
Oh, Carajo, sorry. Carajo, yeah. So let's take you guys one at a time here. Devlin, I'm imagining you're a bit lost because you don't have a calculator today, right?
Yeah, but I have the app on my phone so I can get the calculations. I'm just confused at how we're just slimming it down so quick. I'm confused about it.
Well, Devlin, there's kind of two things going on. Rounding is one issue. Putting things into scientific notation is a separate issue. Let me ask you this, Devlin. On your calculator, do you have an EXP key? What are you using for the EXP key?
Yes, I have an EXP key.
Can you show it to me? Like I want to buy this here, hook, line, and sinker. So show me what it looks like. Oh, you do have an EXP key. Okay. And now are you using the EXP key?
Yes.
Good. That's all I need to know. Listen. We're going to talk about rounding in a minute. For now, Devlin, let's just focus on trying to put this into scientific notation with some number with some number of digits, any number. So is this what you see on your calculator right now, Devlin? Let's start there. Do you have the same number that I have?
No, I have 7.68 times 10 to the 16th.
Okay, so let's clear that out. Clear it out good. I want you to do it one more time with me. And I want this to be the procedure. Anytime any one of us gets lost, we should stop and we should slow down, because with so many students here, Devlin's not going to be the only one, okay? So Devlin, this is the problem we're working on right now, correct?
Yep, 3.2 times 10 to the 9. That's 32 million.
No. That's why you're lost, Devlin. You're doing it wrong. Clear it out. Clear it out. Clear it out.
All right.
I want you to punch what I punch and only what I punch, okay? Punch 3.2.
Yeah.
Now hit EXP.
Mm-hmm.
And now hit 9.
Oh, okay. Yeah, okay. That makes more sense.
Divide by 2.4 EXP5 and hit equals. Is that what you see?
Yes.
Good. From now on, Devlin, we do it my way. There's only one way. There's my way or there's the wrong way, okay? You have to decide which way you want to do it, okay? All right.
Professor?
Yes, Austin.
Yeah, heads up. Some of the like exponents and the decimal points on the Word document are missing. So.
Oh, really?
You know,
oh, yeah. So thanks.
The answers don't have to be the same, but I just want to give you that heads up.
You might want to do because when I did it, I did the automatic convert from PDF to Word, which probably didn't go very well.
Open the PDF.
Yeah, go from the PDF version. Thanks for pointing that out, Austin. I won't send that. That's probably why I didn't upload it in the first place, but then I forgot because it was like a year ago when I did this. So, okay, go from the PDF version, not the doc version. All right, now wait.
Is that shared to us somewhere on Blackboard, or do you email that out like every time?
It is on Blackboard. If you navigate to the lab section on the left, click on lab, and then you'll see lab 1, powers of 10. And right underneath it, you'll see here. I don't want to lose my phone mode here.
If you right click it, you can open it with Adobe instead of Word, because you probably have a default to open a Word.
Just open a new tab, and it will come up right there, right?
Okay, so lab 1, powers of 10 measurement. Now I'm clicking on this, and now I open the PDF.
And there you go.
Yeah.
Right? Okay.
Boom.
Hold on. I got to plug in my phone here because I'm running out of juice.
Okay, it looks good now.
All right, cool. All right, I just plugged myself in here. Class, Devlin, I'm not done with you. Now you have that on your calculator, right?
Yes.
What's your lead digit?
1.
So let's start by writing that down.
Okay.
Put a decimal point after it, okay?
Gotcha.
Now we got to keep some change. How many 3s do you want to keep?
Just 1, right?
All right. If you don't know what you're doing, always do that. Just keep 1. Times 10. Now you got to figure out your power. How many times did you move the decimal place? It started off there. You moved it to there. How many times did you move it?
3, 4.
4.
4.
So that's it. 1.3 times 10 to the 4. Okay.
Yeah, I was just doing the equation completely wrong.
I know you were, but now you're doing it right and things feel good, right?
Yeah, hey, a lot better.
Kara Jo, how are you doing?
I'm doing good. I just didn't hit the divide button.
Oh, okay. Yes. Now listen, guys. It's time for us to shift tack a bit. We're about halfway through our lab and we're almost done with all these problems. I'm going to save this one for last, but it's time for a kid's break. It's time for you to learn some stuff. It's time for you to learn about the art of measurement. And the art of measurement is deeply related to what we're doing here in scientific notation, okay? Let's take a look at this number. Remember back in the day when you took that math class with your math teacher and they told you that if you see a number with 33333, that you should write down 1.3 times 10 to the 4 and you should put a line over the 3 and that meant 3's go on forever? Anyone ever learned that? Aaliyah has.
Yeah, the 3 is supposed to be.
Yeah, I have.
All right. Well, that's bullshit, okay? That's fine if you're a mathematician and you don't have any real work to do, but scientists are concerned with the art of measurement, and measurement is a real dirty job done by dirty little people and their dirty little tools. There is no such thing as infinite threes in nature. Measurements have a quality to them, just like there could be a quality to chocolate chip cookies. Is it a good cookie or is it a bad cookie? There is a quality to measurements as well. And learning about the quality of measurements is about understanding what scientists do. For instance, let's learn a little bit about the metric system here. I'm going to flip over my page and I'm going to have you guys look at my ruler, okay? And, oh, sorry, my shoe got caught. This is the side with centimeters, okay? Do you see this here? This is 1 centimeter. And do you guys see those little tiny tick marks there?
Mm-hmm.
Those are called millimeters, okay? So 1 centimeter contains within it 10 millimeters. You've just learned something about the metric system, okay? These little guys are millimeters, and this is a centimeter. I could also write this a different way if I wanted to. I could write this, if I wanted to be weird, 1 millimeter is equivalent to 1/10 of a centimeter. That's another way to write down what's going on there, okay? How many centimeters do you see printed out in this ruler? How many centimeters? How many centimeters are graded on this ruler?
30.
Not true.
30.5.
Very good. 30.5. Powers of observation. I like it. Don't get cocky, okay? You can make a mistake anywhere. Hey, who said 30.5? Who was that?
Wyatt.
How many millimeters are graded on this ruler?
3,500.
No.
350, Wyatt.
Not 350 either.
Oh my.
Try again, Austin.
305.
There you go, Austin.
Oh
305, because this is 10 millimeters, 20 millimeters, 30 millimeters, 100 millimeters, 200 millimeters, 300 millimeters, and 1, 2, 3, 4, 5 more. There are 305 millimeters on that ruler. Class, every time you take a measurement, you have to consider the quality of the measurement and how carefully it was done. Usually when you take a measurement, if your ruler is graded to the nearest little millimeter tick mark, you'd want to take that ruler to the limit of its precision. This is what a scientist calls precision, but it's what a machinist would call tolerance. The precision or the tolerance is the quality of your measurement. It means how carefully was my measurement taken. Let's say that we had a dumb job to do, and the dumb job was to measure the height of the professor. To do that, we might make use of this meter stick here. A meter stick, let's put this down on the table and I'll zoom along it here. A meter stick contains 100 centimeters. Oof, those millimeters have been rubbed off. How many millimeters long is a meter stick? How many millimeters?
Go ahead, Wyatt.
Sorry?
100.
Fuck no.
1,000.
1,000.
There's 100 centimeters. That's 1,000 millimeters, okay? The average height of a man is maybe 2 millimeters. Let's see if we can do this here. I'm going to try measuring my height. Okay, so I got 1 meter stick. I'm going to need a second one here. Let's measure the height of the professor and let's learn about the art of measurement. If you're good at measuring, when you tell a scientist to take a measurement, you will often specify the tolerance. I want to measure myself to the nearest millimeter, the nearest tenth of a centimeter, okay? So I'm gonna hold this up so I have 100 centimeters. I'll put the ruler up here. I'm trying to tilt the computer so you guys can see what I'm up to here, okay? And this is weird, okay. I'm gonna put this ruler on the top of my head and I'm gonna look over and see what my measure, oh, first you have to put 0 at the bottom. Okay. And I get 178.1. That's my measurement, okay? So I actually took the time to measure myself to the nearest tenth of a centimeter, the nearest millimeter, and when I put my ruler across, I got up to 178.1. That's where my ruler was when I looked over at it. And I want you guys to just meditate on this measurement with me. I measured my height as 178.1 centimeters. Imagine that I took this number and I etched it into a stone tablet and I buried the stone tablet in the Sahara Desert for thousands of years. And thousands of years in the future, someone was to unearth this stone tablet, some Indiana Jones, and they took a look at my measurement. They would say, look at this here dude. This here dude took the time to measure himself to the nearest tenth of a centimeter. He did a good workman-like job because he took his tool to the limit of its gratings, to the limit of its precision. Each one of these numbers conveys meaningful information about my height. The 100 centimeters tells you that I'm taller than a munchkin. 170 centimeters tells you that I'm taller than 1.5 meter sticks, right? 178 tells you that I'm 8 centimeters past the 70 mark. 178.1 tells you if I look really close, I'm one little tick mark above the 8. Each one of these numbers then tells you something about my height. And we would say that this number has 4 significant figures because every number in this number counts. Okay, cool. Now start there and meditate with me. Go on a journey. Another way to look at this measurement, the way a physicist would see it, is they would say that this measurement has a precision of 1 part in 1,000. And that might sound kind of weird to you guys. What do you mean 1 part in 1,000? To measure to the nearest dime out of $100 is the same quality as measuring to the nearest dollar out of $1,000, right? It's because I'm breaking the measurement up into 1,000 parts and measuring them. This precision has 1 part in 1,000. If you take a measurement at the 1 part in 1,000 precision level, that is so sensitive that any small change in your technique is liable to change the measurement. So let's go ahead and let's take a second measurement with me. I'll stand up. I'll do it just the way I did it before. I'll hold the 2 meter stick. I'll go across my head. Bear with me here. This time, I got 177.2. Now, I did things the exact same way I did before. And this time, I got 177.2 centimeters. It's not the same. What is the truth about my height? How tall am I really? Am I actually 178.1 centimeters? Or am I actually 177.2 centimeters? What is true and what is not true? What do you think?
I would say you're the average of the two measurements.
Well, but what if I take a third measurement and it doesn't come out to be either of those two? Then what?
You're the height of the measurement that you took most precisely, because it
No,
might have.
whoever said that, I want to correct you right now. That's a false way of talking. Look, these measurements have equal precision because they both have 4 significant figures. These numbers are equally precise. Do you understand?
Yeah.
There's a difference between precision and accuracy. Precision is how many sig figs or the quality of the measurement. What you meant to say, Wyatt, is you're imagining in your mind of minds that there is some one height that is my real height, right? There's some truth to be achieved. Accuracy is how close the measurements are to the truth. Precision is how many sig figs you have, what the quality of the measurement is. Does that make any sense?
Yes, in the accuracy of your measurements, whichever of those measurements is more accurate.
But we can never know which is more accurate, right? In fact, Wyatt, the way to do it to be 100% sure is I would have to measure myself 100, 1,000. I'd actually have to measure myself an infinity number of times and then take the average of those infinity measurements. That would be the way to do it, right? But that's a lot of work and I'm lazy. So let's just do 3, okay? Let's just do a third measurement and then we'll call 3 as close to infinity as we're gonna get for the amount they're paying me today, okay? So we're gonna do a third measurement. I'm gonna try to do it the same as before. 178.4. Bear with me, guys. I'm trying to tell you a story here. And I don't know if you have ears to hear the story, but I'm trying. So Wyatt's idea is, why don't we take the average of these measurements? Let's all do that together. We're going to add them up, hit equals, and then divide by 3, okay? So I'll do 178.1 plus 177.2 plus 178.4. I'm going to hit equals, and then I'm going to divide by 3. Fuck. All right. No, I lied. That's not what happened. It was 178.3. Okay, damn it. All right. Let's try this again. 178.1 plus 177.2 plus 178.3 equals divided by 3. There we go. That's what I wanted. Sorry, I made an error there. Okay. I was talking with Wyatt. Wyatt, what am I supposed to make of all this? Like, I took these measurements of my height, and that's what the calculator spit out when I took the average. So what does it all mean? Like, what is my height?
Could you turn that, like, every number after the decimal and turn it into like a fraction, and then maybe that would be precise?
No. That's not how it works. Okay. I only measured myself. The quality of my measurement was to the nearest 1/10 of a centimeter or the nearest millimeter, correct?
Yeah.
Just because I put a bunch of numbers into my calculator and I take the average, that does not mean I suddenly know how tall I am to the nearest 100th of a centimeter, the nearest 1,000th, 10,000th, 100,000th, millionth. I did not measure myself to the nearest 10 millionth of a centimeter. That would be measuring myself to the diameter of a carbon atom in my hair, right?
Yeah.
I did not measure myself to that level of goodness. I was not that precise. Do you see what I'm saying?
Yeah.
So in other words, Wyatt, some of these numbers are real and some of these numbers are fake numbers. And I need to know which are the real numbers and which are the fake numbers. So what should I do, man? How should I deal with this?
You should round it then. Down
Very
to,
good. And what should I round it to if I want to be honest?
You did to the thousandth, so you would round the 8 to a 9.
Very good. Or in other
1/7.
words, these numbers all had 4 significant figures, correct, Wyatt?
Yeah, so we want
So
4
I should
significant
keep
figures in our answer.
1, 2, 3, 4 significant figures. And to the best of our knowledge, then, my height is 177.9 centimeters. That's how we do it. You see, this is what rounding is all about, my little friends. It's about knowing which numbers are real and which numbers are not real in your calculator. The rule goes like this. If you're going to do math with a bunch of numbers, you should always round your answer to the crappiest measurement. Here, all of my measurements were equally crappy. They were 4 significant figures. So I kept 4 significant figures. Let's look over here. How many significant figures did the top number have?
2.
How many did the bottom number have?
2.
How many do I get to keep?
2.
So whoever rounded this, I think that was Devlin, he did it right. Let's look back up here. This is where Stacy helped me, right? How many sig figs does the top number have?
3.
Bottom?
2.
2. How many do I get to keep?
2.
2, says Austin. We should not have kept the 3. The 3 was a lie. Fix it. That's okay, Stacy, we're learning. Let's try the next one together. We're going to punch in this last one. 2.99792 EXP8 divided by 5.520 EXP minus 7. Oops. Divided by 5.520. By the way, I don't know if you noticed what happened there. Do you see this key? That key is your backspace key. Very useful to use from time to time, okay? All right, hit equals. Is that what you see? Yes, I like it, Stacy. Show me if you got it. Stacy, that's good. Who else? Anyone else got that number? I'm just trying to see who's with me here. Hold that up, Emily. Emily, that looks good. Ty, didn't you have a calculator? Why don't you show me what you got? Play with me. So Kate, yes, that looks good. Arunsak, that looks good. Come on, Ty, you're not, wait, did Ty just stop sharing her video? Does he hide from me? Wait, no, where are you? I can find you. Okay. Come on, Ty, punch it, do it. It'll make you strong.
Hold on, can you show me the problem again?
Yes, I can. 2.99792 EXP8 divided by 5.520 EXP negative 7.
How do I do the negatives?
You use this key right here.
Okay.
Make sure you hit the EXP, right?
Yeah.
Show me. Oh, yes, that's good. Tifany, I like it. Paul, I like it. Ty, I like. Wait, Caroline, what's that kitty's name? Let me see, Christopher. Christopher, that looks good. Caroline, I like your kitty. What's your kitty's name?
Her name's Paris.
Hey, Paris. Beautiful cat. Ty, did you ever get that?
Yeah.
Oh, good. Yes, I like it. Okay, so Ty, how many significant figures does my top number have?
6.
Good. How many does the bottom number have?
4.
How many do I get to keep here?
2?
No.
Or 3?
No. You get to keep 4. You get to keep the same number as your crappiest number. And this is your crappy number, okay? So what should I round it to?
5, 4, 3, Do you put the decimal after
After the
1?
5.431. There's your 4 sig
Okay.
fig. But you need to do it times 10 to the 14. You don't mess with that. That's sacred, okay?
Okay.
Times 10 to the 14. You guys got that?
Mm-hmm.
You guys got that? Okay. Let's talk for a hot moment here. There's some other parts to this lab today, but I've got a better idea. You've all had some practice on scientific notation. I'm sure you're getting a little zapped, right? I want to end here because I think it's going to take us a few minutes just to figure out how to upload the photos, and I want us to learn how to do that. Remember, I'm going to have to grade you guys, and there's a lot of you. If you start giving me crazy ass formats that I can't read, I'm going to give you zeros until I can read it. And it's going to make things real messy for you guys and for me. So we're going to take these last couple of moments here, and we're going to figure out how to do a good job uploading the assignment in a way that I can see it. And then we'll be done with our work today, okay? Sound like a plan? And by the way, Devlin and Ty and everyone who has it, you're going to get the real calculator, right? I don't know if Devlin's even here still. Are you hiding that? Yeah, okay, cool.
I have a question.
Yeah, let me find you. Who are you? Who's talking to me?
Aaliyah.
Oh, hi, Aaliyah, where are you? I can, oh, there you are. Okay, so I can only see a few boxes at a time. Yep, what's up, Aaliyah?
So as we keep going forward, you know how like there's a simplified way to like solve these problems by just like subtracting or adding the like little exponents. Will we be able to just do that, or do you still want us to use like the calculator and everything?
I actually want you to use the calculator for now. Yes, eventually we can start using those tricks and they'll come in naturally. But honestly, Aaliyah, nothing is easier than just punching the buttons in and hitting EXP. You know what I mean?
Yeah, all right.
Aaliyah, the thing is, we're going to have cool stuff to talk about, like quasars and nebulas and black holes. I don't want you guys getting tripped up on the exponents. I want you thinking about the cool stuff. So this is the training on how to do the lame stuff so that we can have discussions about the awesome stuff. So you'll see. What's going to happen is we're going to do these problems together so many times that you're all going to become really, really good at this. And it's going to happen natural. And I'm always going to be here to do the work with you. So as long as you're willing to sit there and punch it in, you'll learn, okay?
Yeah, that's great.
Okay. Let's say this, class. For today, this will be the only page that you'll turn in for me, okay? We're just going to turn in this one page. That's our entire lab. I know there were other pages. Let's not do that. Let's not kill ourselves, okay? Let's just do this one page. We have enough to do as it is. All right. Let's talk about how you're going to do this. Let me stop my share. I need you to either scan it or take a photo of it, but I need that photo to be a JPEG, or I need that photo to be, a PDF. So here I'm going to have to break down the weeds with you guys. Show of hands, how many people are using iPhones? Just put your hand up if you're using iPhones. I figured there'd be a lot of you. Okay. And probably a couple of you have Google phones. I'm guessing the others have Google phones. Thank you, Tifany. Yeah, Caroline. Caroline and Paul, people who are using Google phones in Austin, I might need your help.
iPhone.
Oh, sorry. So Caroline and Paul and anyone else who's using a Google phone, I may need one of your helps to show me how to do this. It may be that Google phones automatically take a photo as a JPEG, but let's say you're using iPhones. I'm guessing a lot of you have I'm rocking an iPhone 5. Look at this little guy. They don't do that anymore. I bet you guys, oh, do you have an iPhone 5, Kevin? No, you got a fancy one. Yeah. You got the crazy ass 5 camera X. Okay, good. So Kevin, you're the kind of person I want to talk to right now. If you have a modern iPhone, I need you to change your camera settings. So go to settings. Okay.
You were talking about earlier. I did it.
You did it? Oh, thank you. Reardon. Oh, Reardon, it's so nice to see, or I can't see you, Reardon, but I'm glad that you are back. Reardon took my solar system class. It's nice to have some friendly faces in the troll section here. So look at what Reardon says in the chat. You go to iPhone, settings, camera, format, most compatible. Can you guys click most compatible for me? That way I don't get an HEIC file, but I get a JPEG. If anyone's having trouble following this, please talk to me. Paul and who was the other person? Caroline. Can you guys figure this out? I don't know if the Google phone does. You know what we're going to do? We're all going to try to upload the damn document, and we're going to see who's doing it right, and we're going to see who's doing it wrong.
Hey, anyone who has an iPhone, if you utilize OneDrive, you could also just save it to OneDrive, and then it will automatically be a JPEG.
Oh, really?
And it will be on your computer as well.
Austin, you are a damned genius. Whatever he said, I'm not sure I understood any of that, but do what he said, okay? You save it to OneDrive?
Yeah, hold on here. Let me try and do this real quick.
I can even give you permission to share your screen, Austin.
Well,
They probably took that feature away from us too.
Hold on. Near my video. Okay. All right, give me 1 second. All right, you guys can see my phone now?
Yeah. Hold on.
So
let me hold on. Can I lock on you? I'm gonna go speaker view.
Yeah, go ahead.
Yeah. Okay. It's a little fuzzy, Austin. Hold it back a bit. Back from
Okay.
It's still fuzzy. Hold it up closer.
I can try. I mean, I don't know. Here, maybe my front camera will be better.
Well, what did you do, Austin? Tell us how you did it.
All right, so let me show you. I'm just taking. This is my photos. Took the picture, and on the bottom left, obviously the share button, and then I'm just going over here to OneDrive.
Oh, killer! That's easy.
And then all I'm doing is just uploading it to OneDrive. So I have the file already made. But if you just press upload,
it automatically saves it as a JPEG. You said if you go to OneDrive.
Saves it as JPEG. And now, we get free Office. So now in my OneDrive, I have this picture here. And now I can, as a JPEG, it'll be on my computer. Now I can just upload this.
Okay, so can you do this to me? Now, guys, Austin, I'm going to go to my screen, okay? So, guys, watch me. I'm going to share my screen with you. So here's what you do. Once you have it as a JPEG, let me get out of here. Let's navigate over to Blackboard. This was our first lab, Lab 1, and click on Lab 1, Powers of 10, Measurement. And then I want you to upload it, browse my computer, and upload the JPEG. Now, Austin, I want you to upload it, and we're going to see what yours looks like so everyone else can see what's going on, okay? Because,
Okay.
Austin, you
want me to share my screen?
No, because what I want to do, Austin, is this. Look at my screen. I want to go to Grading Center, and I want to go to Needs Grading, and I want to see if anyone's submitted yet. No one's.
All right. So where do I submit this? I'm sorry.
Go over here to Lab.
Okay.
Go to Lab 1, Measurements, Powers of 10. Okay.
Oh, okay, got it. All right.
And then if you scroll down, go to Attach Files, browse my computer, and then pick your thing, okay?
Let me grab this.
Now, there's probably 40 of you in this Zoom call, so could a couple of you start uploading so I can see who's doing it right and who's doing it wrong?
Is that a file name? You should have it.
I'm sorry, Aaliyah. What did you say, Aaliyah?
I just tried to upload a picture from my phone and it didn't go through at first, so I'm trying again.
Okay, yeah, try it again. Because we're going to have to figure this out if we're going to be able to submit work to each other, right? I'll keep hitting refresh. Oh, well, okay. Everyone, watch this, okay? Everyone watch my screen. Let's see who's doing good and who's doing bad. I want you to see a version of good and bad. So we got Chris, Timothy, Tiffany, Cole, and Joshua. Let me attempt to grade them, and let's see if I can see what's going on. This is an example of a good submission. Can everyone see how when I call up their thing, I see the grade, I can see the image in the box? If you can see your thing in the box, that means it's good. I want to be able to see it in the box when I load it. Let's go through a couple more. Here's Timothy's. Takes a second to load here. Timothy, you did a good job because I can see your work in the little box. Let's keep going through here. Tifany, you did a bad job. You did a shit job. Not only can I not see your assignment in the box, but you've also uploaded it as a PNG, which I cannot read with any of my programs. So wherever you are, Tifany, I need you to do it different, okay? Do you understand? This is the kind of thing I'm talking about. Tifany, talk to me. Where are you? Are you a troll? Who are you? Oh, Tifany, there you are. I see you now. Tifany, did you take a picture of this with an iPhone?
Yes.
Okay. Did you try the OneDrive thing that was it Nathan? What the hell am I forgetting?
Austin.
Sorry, Austin.
Can you do that again?
Austin,
Yeah.
Austin, they want to see that again, Austin.
I don't have that.
I think you have to download OneDrive onto your phone. I'm not sure if it's on
the app.
You can also upload images on the web, and you can convert the files over to whatever you need, JPGs.
Oh, you mean like using one of those free web services?
There are a lot of online free file converters.
Guys, I think that's fair. You could do that, but that sounds complicated. I think it would be easier for Tifany just to change her settings to most compatible format. I think that's the best way to do
Well,
it.
as nice as I sound, my thing isn't working, so maybe go with whatever.
Where are you, Tifany? I've lost you. Tifany, I'm scrolling through the people looking for you. Tifany, what do you want to do? Do you want to change your settings to most compatible, or do you want to use the OneDrive? What's your pleasure?
I did change it to the most.
And it still turned out as a PNG?
Yes,
Did you
but
upload it from your phone?
I did.
Do you have an iPhone or a Google phone?
I have an iPhone.
Let's have you download OneDrive. Austin, you had to download the OneDrive app, correct?
Yeah.
And that probably takes 10 seconds, right?
Maybe 5.
Do you download the OneDrive onto your computer too?
Yeah, so that, do you have a Windows computer?
Yeah.
Yeah, on the bottom left, it should just come pre-installed.
Is it supposed to look like that?
That's good. Yes. Now,
Okay.
Tifany, I've given you guys multiple uploads. So, Tifany, could you try to upload it again and we'll see if you got it right this time? This
Yeah,
is
let me-
exactly the kind of thing that I wanted to work out. So let's keep scrolling through the submissions here. I'm sorry?
Could you look at my submission? Because it was giving me some trouble, but it may, I believe, the one.
Yeah, I have to go through one at a time. So here's Cole's. Cole, you did a great job. Thank you, Cole. Let's
print it out. Wow.
Yeah, that looks nice. Joshua, you gave me a JPEG, but it's like a hyperlink. This kind of shit really screws me up because I have to click on it, which takes me outside of Blackboard. And that's really irritating because then it kind of messes with my flow. Now, Joshua, I suspect the reason that it made it a hyperlink is because your format is too large. So I think what you need to do is choose like a smaller size format. I don't know if you're out there, Joshua, but Joshua, you were a student in my 1010 class, weren't you?
Yeah, I used Cam Scanner for my image.
Can you have Cam Scanner convert it to a PDF? That might fix your problem. I don't know why sometimes it uploads it as a hyperlink, but I don't want a hyperlink. I want to see it in the box. Let's keep going here. So Joshua,
I'll give it a shot.
Give it another shot. Let me keep clicking here. See who's doing good and who's doing bad. Oh, that's it. That's all I got. I got five attempts. Right.
Did you get mine?
Let me go back to needs grading. Let's see who else. Needs grading. Okay, I've got oh my God. There's so many of you. I'm so freaking scared about how I'm gonna do this. Okay, who's curious? Well, let's just go through them all, damn it, okay? I've got 19 now. Let's see who's doing good and who's doing bad. Christopher, you're good. Timothy, you're good. You understand why this is important. There's so many of you. I can't have you all turning in crazy stuff. Cole, you're good, Cole. Joshua, you're bad. Cameron. Oh, this is so irritating. Cameron, you're giving me sideways stuff. Can you give me not sideways stuff, Cameron? Can you make it normal for me? Paige. Paige, you're good. Jack. Jack, you're bad. PDF is okay, but like, I don't want the hyperlink. I don't know why it's a hyperlink. Can you figure that out? Maybe your format is too large. Christopher. Christopher, you're good. I should see it as a preview in that box. Donovan. Donovan, you're good. You're a little small. Donovan, you're really tiny. Can you make that a little bigger for me, bud? I mean, Jesus, I'm going to go blind looking at your stuff. It's so tiny. See what happened there. I don't know what it was, okay? So you're kind of good, but you're tiny. Reardon, it's a hyperlink. Could you make it? I don't know why some people are getting hyperlinks and some people aren't, but the hyperlinks are bad for me. Austin. Austin, you're good. You're real good. That's a nice. Ooh, I like your stars.
You like that, right?
Yeah, that's some jazzy stuff.
Quality note taking.
Emily.
Professor, I have a quick question.
Sure.
You mentioned something about if I wanted to just resubmit an edited PDF, if it's properly formatted, could I just do that?
Yeah. Yeah,
Okay.
like you mean like you wrote the answers right into the PDF?
Yeah, like I take the PDF, extract it, and then just overlay the answers, or just edit them on, or type them over, and then export it as a PDF and just give it back to you.
Eric, that sounds awesome, but I have one stipulation. If you're going to put numbers in scientific notation, you got to make it look good with an equation editor, right? Can you?
Yeah, of course, of course. Yeah. Properly formatted, I'll do that.
Then, yep. Look at it this way. As long as when I click, I can see it. And by the way, Emily, it would be nice if it wasn't sideways. Sideways, I mean, you know what I'm like? I don't have to be grading my homeworks like this, you know, like guys, to appreciate what's going on here, there are so many of you. And if everyone's submission is crazy, I'm going to have a mental breakdown. I'm like going to lose it. There are so many of you. I need you all to kind of have it together here. Otherwise, this is going to be insane. So let's
I'm sorry, I have a question. I'm pretty sure mine's sideways too, but I took it the right way on the phone. I don't know why it went sideways. How do I fix that?
Can we crowdsource that? Does it? See, you guys are used to
it from your phone.
You have to go into edit your, so like on your phone and go to the picture and then click edit picture.
All right, hold on. I'm there. Yep.
Your edit picture, and then it should have like a little crop thing down at the bottom so you can crop the picture.
Yep. But it's like it's right. I don't know why it went through.
Oh, really?
Oh, it's the correct orientation in your phone. Yeah, sometimes I've seen this when I've uploaded my pictures to my computer. Sometimes you have the right orientation on your phone and they rotate it for you.
Yeah.
Does anyone
I don't want to be a troll.
Yeah. I don't want you to be a troll. Does anyone know what's going on there? Because I don't know what's going on.
I have no clue what's going on at all.
How did you send it to your computer?
Seriously.
I did.
Why if I had the right idea? Stacy.
How did you send it to your computer? Because I emailed it to myself.
I sent it to myself, and then I saved it on my desktop, and then I browsed my computer, found it.
That's Stacy.
Hold it on the desktop and then look at it. Might have automatically rotated.
Stacy, I got a better idea.
Yep.
Just upload it from your phone. Go on your phone if you have a connection to the internet.
Yes.
And go to Blackboard on your phone and directly upload it from your phone. I suspect that when you dumped it onto your desktop, that's when the desktop rotated it, because the desktop will rotate pictures. So try
I'll do that now.
from your phone. Hey, Devin, your stuff's a hyperlink. I don't like it. Can you make it display somehow? A hyperlink is better than nothing, but Daniel, I can already tell this is going to be good because I'm seeing the dots here. It's going to take so long to grade you guys. I'm really scared. I'm used to dealing with half the number of students each semester, so I don't want to start off the year complaining with you guys, but it's very terrifying to have so many of you. I don't mind teaching you. Hey, who is this? Daniel, your stuff is weirdly tiny as well. That will be extremely hard for me to read. If I can't read it, I'm just going to give you a 0 and move on, okay? So that's why we got to make sure we get this correct. Jacob, it's a hyperlink. Fix that. Caroline.
Professor, going to bother you with one more question. I'm sorry.
This is what we're here for.
The labs, since there's labs and like homework, did you want the labs? Because I just don't have the calculator for today or anything. Did you want it like submitted by a certain time each week, or by the end of class, or by the end of the day, or?
Yeah, let's talk about that. With 150 students and the fact that we have 2 assignments per week, Eric, I know sometimes people have to go to the dentist and may not be able to like watch the video until later. But the problem is, Eric, if everyone starts submitting stuff 1 or 2 weeks late, it's going to turn into absolute effing chaos because there'll be all kinds of different assignments from different times coming in. So let's say that by the end of the week, okay, you have all your stuff in. So if you need an extra day, that's fine. Put it this way, Eric, I'm going to try to be in the habit of grading everyone's stuff on Sundays, right? That will be the worst day of my week this semester. I get my ex-girlfriend called it the Schmondays. I start to get really sad and depressed around Sunday because I have to sit here and grade like 150 papers and I'm going to want to kill myself. Okay, so let's say by Sunday you have it all in. That gives you an extra day if you need the time to do stuff. You know what I mean? But you can't turn it all in like 2 weeks from now because that's going to be too crazy. So I'm trying not to put a hard deadline on it, but if I'm grading them on Sunday, you should think of that as the day to have it in by. Does that make sense?
Yeah, that's perfect.
And
that's for everything, right?
Yeah, I know that I'm being a little bit annoying here, but my thought is if we just get this out of the way now, if we all figure out how to make a good submission, then the rest of the semester will be smooth. So Caroline, you're doing a great job. I like what I see here. Stacy.
Yeah, sorry.
That's all right. It's the Blackboard is really slow and clunky.
Yeah. I tried to do it on my phone and it's giving me an adjustments.p list. So I don't know. I'll figure it out. Don't worry.
Oh,
I got
you. I can't read the P list. The P list is no
good.
Yeah,
so I tried to do it through my Blackboard on my phone and that's...
Did you change your camera settings to most compatible?
Yes, I did. Yes, I did.
Does it have a thing for how big? I think you can also choose your photo size. You don't want to choose the largest and you don't want to choose the smallest. You want to choose like medium or large. Does it have like the format of like how big the picture will be? See, I don't have one of the fancier iPhones. So I think in my camera settings, I can choose... Let me go to my camera settings really quick.
Yes, it says small, medium, large, or actual size.
You want to choose large or medium. Wait, how big is large?
Large is 499.
Yes, choose large. I think that's what you want. Now take a picture again and try to submit that, okay?
Okay.
Brian, can you check mine?
Yeah, I'm scrolling through them. Stacy, yours just came up blank here. Let me just... Yeah, Stacy, you're sideways and you're too small. So change it to large and upload it from your phone or figure out what the hell's... You know what? Go to your computer and rotate it on your desktop. You should be able to rotate it right from your pictures. Then submit it, okay?
Okay.
So don't send it from your phone. Do the computer thing and rotate it and save it as large format. Whoever asked me, I'm going to look at yours too. Here's Kaitlyn's. Kaitlyn, you're looking awesome. Kaitlyn's good. Craig. Sorry, Wyatt. Wyatt, you're looking good, buddy. Wyatt's looking good. Now, who just asked me about theirs?
Me, Jeffrey.
Jeffrey, let's see here. Where are you? Jeffrey, you know what's weird is if I try to grade this, I just want to grade you. Oh, there we go. Okay. Jeffrey, this looks great. Oh, okay. Jeffrey, you made a mistake here. I would take off points for this. It's 3.5 times 10 to the 0.
Yeah. Okay.
It's 10 to the 1. You got to fix that, okay? Fix
Gotcha.
that, re-upload it.
Could
Re-upload?
you also check mine too?
Yeah,
I re-uploaded it, so it would be straight.
who asked me that? So
Emily?
Oh, hi, Emily. Let me
Hi.
see here. Emily. There you are. Come on. This is what takes a long time. Oh, Emily, that looks awesome. That's beautiful.
Can you check mine?
Yeah, wait, but Emily, this is a teachable moment. Stacy had the same issue as you, Emily, where hers was sideways and small. How did you fix it? Did you just rotate it on your desktop?
When you take the photo, there's a way to rotate it in the edit settings of your camera roll. And then I just like sent it to myself, so and then I uploaded it on here.
In other words, you rotated it on your phone first.
Yes.
Weird. Okay. Who just asked me to check? Someone else did.
It was me, Arunsak.
Arunsak, let's check you out here.
Hey, Professor, I have a question for you.
Yeah.
So if we're doing the homework at, your study hours, and we're doing the labs in person and submitting them like those days, what are we gonna have to do from home? Is there like a Pearson or McCormick thing or a McGraw thing that we work on?
Dude, get ready for this. All right, I'm about to blow your mind. You're not gonna have to do anything at home.
Read the book, nothing? Just
Read the
show
book.
up class and do stuff.
Read the book. Find cool articles in space. I have cooked the books so you don't have to do anything at home. Do you see? That's why I'm doing it this way, so that we can do all the work together. That's going to be a virtue of our plan. That's going to be part of what makes this work. Now, yes, read the book. That's what you want to do. Read the damn book. And I want to do all the work with you, Austin, because I want it to get done right. I'm worried that if I let you do it on your own, you're all going to go off in 10,000 crazy directions. I want to show you how it's done right, so that when you go into your future science classes or your future classes, you'll know what a damn fine assignment is supposed to look like. So there's a reason for there's a madness to my method, okay? Okay, so you guys got a sense of it. Let me just say, because at some point we should stop here. By going through those assignments with me, you got to see what a good submission looked like and a bad submission looked like, correct? So make it look good. And if not, I'll be telling you 0 out of 10 until you fix this, okay? Kara Jo, are you okay? I thought for a second that you were having a meltdown there.
I have no clue what's going on.
Did you?
I have no clue how to submit this. Huh?
Did you submit your assignment?
I don't know. I don't think I did because you don't see it, so I don't know what I'm doing.
Well, Kara, we got this. Just take a picture of it. Let's see.
With my regular camera?
Yeah, just with your regular camera, and upload the picture. I don't see you here, Kara Jo. So.
Okay, upload it to
Blackboard. So navigate to Blackboard, go to Lab, click on Lab1.
Wait, no, I don't have that on my computer.
Oh, you log into, do you have you just have to go onto the internet. You have to, how did you get my email? I'll tell you, let's do this. In a second, I'm going to stop class, and Kara, you stay on with me, and you and me will troubleshoot your problem. Okay?
Okay.
Kara, you and me are going to do a little one-on-one thing here. Let's talk about the rest of you. Do you have any issues or questions before I end for the day?
Would you mind just checking Devin Irons again? I just want to make sure my second attempt works.
No, I'd be happy to. So that was Devin, right?
Yep, Devin Irons.
Okay, let's go to needs grading.
Would you mind doing mine after that?
Nope, not at all. That's what we're here for. So Devin, let's check you out. Where is Devin? Devin. Okay, Devin. Devin, you're looking good. Who is the other person?
Donovan.
Donovan. Donovan, where are you here? Donovan.
Check Daniel as well after.
Yep, we'll check everyone. Donovan, your shit's looking good. Who's the who else?
Daniel, DaCosta.
Daniel DaCosta. Where are you here? There you go. Okay, yeah, so this is a little annoying, but we're getting it. Daniel, this is good. See, after a few takes, now you'll know what looks good and what doesn't. Anyone else want me to check?
Mine too.
Who is that nice person? Who said mine too? Sorry?
Reardon Mario, please.
Oh, Reardon. Yeah, sure, Reardon. There you are. Reardon. Reardon looking good. Looking real good. Who else?
Aaliyah, can you try to check mine?
Aaliyah, I got you. Hold on.
Because I'm not sure if it even sent as like a PDF.
I see it. I see your name anyway. Let's click here. Okay, so it's a PDF, Aaliyah, but it's giving me the damn hyperlink.
Yeah, I'm going to try one more time. I'm going to try to send it on my computer instead of my phone.
Do you know what I think happened? Do you know why I think it sends it as a hyperlink? Because you took the picture as you kept the file format as regular size, the large size. Like I was talking with Stacy about, you want to save it as a large image. I think it did that because the size of the photo was too many megabytes. So try to store it as a slightly smaller size. I think that might help.
What's going to happen if you have multiple pages to upload, Professor?
I'm sorry?
What's going to happen when we have multiple pages to upload?
In my experience, once we figured this out, once we get it right, even when you have multiple pages, it'll still display them correctly. What we want to do is avoid this kind of thing, you know? We want to have them displaying the way that the other people's were displaying. Like the way, let's look at Connor's here. Come on. I can't imagine what this is going to be like grading you guys. It's going to be so crazy. There's a large number of you, but Blackboard is really clunky like this. So like, I constantly have to hit refresh to get it to maybe I should close some tabs or something. Oh, by the way, one last thing before, all right, this is getting ridiculous. I'm gonna have to stop at some point. Guys, let's talk about when I upload the videos, okay? After this class ends in 2 seconds, I end class. It takes roughly 1 hour for the video to render. Then it takes 1 more hour for me to upload it to YouTube. So if you ever miss a class, or if you're a night student, the video won't be available until it's 2:30 now, right? So think 3:30, maybe 4 o'clock, or maybe 4:30. If you ever lose track, I will be putting the videos up in 2 places. First of all, I have my own YouTube channel. You can see this was the class that I did yesterday. And I'll be putting them up there with a name something like this, AS1020 Fall 2020 Lecture 0. Today we did Lecture0-LAB1. I'll also try to put them on Blackboard in the announcements section. I'll try to upload the hyperlink just like you have for the intro video here, okay? So I just wanted you guys to know that if you ever have a dentist appointment or if you miss class, that's where you find the videos. Hold on, I got a chat coming in here. So I know some of you don't have cameras and microphones. Okay, Stacy, you figured it out. Wonderful. Would you guys like to ask me any questions or any issues before we end today? I know you're probably getting pretty zapped
We
up.
don't have to do anything from now until Thursday. Just show up.
Just show up, baby. Oh, yes. You have to get the bloody calculator if you don't have the calculator. But if you have the calculator, Austin, you could read the book if you want to, but all you got to do is show up and hang out with me. I'll take care of everything else, okay?
No, I don't need to buy the book or any access code because Chris gave me the book.
You might want to buy the book just so you can augment my lectures a bit. It could help. But you could probably get away with not buying the book if you take really good notes.
It's an expensive book.
All right. Oh, by the way, Chris might have also helped with that. Okay.
He's the MVP of the year.
MVP of the year, right. Okay, guys. I've had fun hanging out with y'all. I'm looking forward to a good semester. Make sure that if you haven't gotten your thing uploaded, upload that lab. Try to get the format right. Cara Jo, you can stick around with me, and we'll troubleshoot your thing. Okay. So I'm gonna stop the recording.